net port labels are not aligned. You can see these ones are aligned, but here this one is not aligned with that. You can align like this, right? And this is not aligned with previous one, so you can move something here to make all these things align. So this is another small mistake. Yeah. Other than that, here also he is intersecting this uh, the component details with the wires. So he should move this way. If there is not enough space, you can move there, right? So try to follow a convention. Yeah, those are the big mistakes I have seen. And he is like not in like lot. He's not input any images. Like I told you, input some logo or something like that to here. He not given any try. He, yeah, his name is there, title is there. That's also fine. Yeah, that's good. Overall, it's good. Another big mistake I told you to put some boxes over there, right? So like I tell you, draw a box and change the properties of the box to dash, right? So that part was forgotten by him, I think. So overall, it's good, but I think he didn't design the PCB layout part. He only shared the schematic part with me. Okay. Overall, good job. All right. Let me open it here. Okay. When it comes to this, yeah, she put it her details, and it's better to put a logo here. It's fine. She used the boxes to separate the separate circuits, and yeah, power connector is there. Here it's better to like move this LED there, right? Like it's there, no? So it should be like in a good places there, right? So if it is there, like it's on the edge of the wire, right? It's look ugly. Otherwise, there is no issue. It will be definitely connecting, but you should be like do it like in a beautiful way. This one is fine. Yeah, here also buzzer we name this as a designate of the buzzer is LS. And the ground, this is also fine. It would be like look good if you move it the way here. Here she is connecting two similar names. What is the mistake she had done? In the LCD connector, one is SCL and one is SDA, right? So SCL and SDA is there. So she forgot to rename that. After putting net label, you should rename SCL and SDA, right? SCL and SDA. Otherwise, like it will be connecting to the buzzer pin, this one. Like in the previous one, this one connecting to this 15 pin, and also this one is also connecting to this, right? So it is wrong, right? So you should rename the pins correctly. That is a big mistake. Okay, so what are the other mistakes? Yeah, that's fine. Okay. Other than that, when it comes to the naming, you use capital letters, MOSI capital, SCK capital. All the naming things are capital other than the buzzer. So try to do this naming thing in a similar way. If you use capital, use capital letters for entire your schematic. Other than that, I think this is a pretty good job. Yeah, well done. And let me see layout. She not completed yet. I think she may be stuck somewhere. Yeah, I told you about to route those things in one layer, right? So let's see my design. This is my design. I used only top layer, right? In the bottom layer, there is only two connection. I told you about this jumper thing, right? So when it comes to top layer, all of my PCB connections are there on the top layer. But I think when it comes to her design, uh, like she tried to route using both two layers, bottom and top. So then she got stuck, I think. So here she can't find a way to go there, right? That's I think that's what the problem she faced. So try to like that's why I told you try to like place those components like intelligently here and there, yeah, like you should be able to route in the end of the day. That's the big mistake. Like try to use the one layer routing other than going to the bottom layer. Try to route on the top layer. If it very hard, go to bottom layer, right? Because of we are designing one layer PCB. Other than that, this would be fine. Like if we are manufacturing from PCB from China or any other country, they have the capability of manufacturing two layer PCBs in a very good manner. So other than that, this is a good design, but in this session in the Medibox, we are designing only one layer PCB. So in that case, you should be able to design this on a one particular one layer. That's the mistake, I think. Other than that, yeah. What is this connection? This is bus. This is 5 volt. There is some mistakes in the schematic also. That's why some pins got like name like this. Otherwise, it should be have a proper name like buzzer, button, and 5 volt. So there is a mistake in her schematic. Some naming convention. I think you saw that the buzzer naming was wrong. That's what the problem I think. Yeah. Let's move to the another design.
Lanka, I also like to add something to that.
Yeah.
Yeah, and in the layout, actually, we can see the 90-degree bends that I think. So, like, if we can eliminate these things, it would be better because, like for an example, if we try to manufacture this PCB from like a person from Sri Lanka, then these 90-degree bends would be harder to manufacture. So because of this manufacturing techniques, and I will be also discussing about that in my session. Like so, therefore, try to like eliminate these 90-degree bends that that is harder to manufacture like in Sri Lanka. But like if you like over that is also discussed today, so that would be okay. But try to like eliminate these 90-degree bends and only keep two angles, which is like 45-degree angles when turning. That is better. Yeah.
I'll go deep enough for that. Yeah, let me go another design. Okay, this is another one. Let me open this. Yeah, when it comes to this microcontroller circuit, looks good. Here. It's okay to like move it here. there. So it looks nice, right? Now it looks nice. Yeah, that's fine. And here also, I think this is look some like ugly way. So it's better to like that. And here also, these all the net ports are not aligned. So try to align this. And here, what happened? Ground name was moved there. Ground name should there, GNT, somewhat near the ground, right? This is a mistake. Um, yeah. Yeah, microcontroller circuit would be fine. Power circuit, okay. Power circuit, what is the input? You're giving a 5-volt input, right? It's not 5-volt. This is the you are connecting your battery here, so it should be VCC or power input or whatever name you can put here. This should be your input power. The input power goes there. You put VCC here, but if you not put VCC over there, it will be not connecting, right? So it will be a like huge mistake. So okay, here. So you can see the wires are like came here and bend there and going through that. It would be like nice if you put like this, right? And here like the connection is more near to that. Try to move something away, small things away. It would be nice. Yeah, someone can understand clearly. If you like move there, like it will be like not a good thing to do. Here also, it's better you move your wire there. Small mistakes. It's not a countable thing. And here also it like this. This is good. This is good. Oh, what happened to it? There should not be. I think wire, extra wire is there. That's why a red ball came in. Now it's fine. The red ball comes when you are connecting two things, right? So here there was a red ball. There was some mistake. Here also you are intersecting wires with your design names. Common mistake. Other than that, it could be fine. Yeah, it would be better. You can insert some logo there. Yeah, that's a good design. Good job. Let me go to layout design. Yeah, in the first look, like this is not very nice looking PCB because like you can see the clearance. Clearance is very small. I can let me see. The clearance is 0.25. 0.25 would not enough. At least you should have 0.7 clearance. Like if you are manufactured in Sri Lanka in your own, I mean in your own, like we will be teach you how to design your own PCB in your home today, and like it will be better like you set a clearance more than 0.7, right, centimeters. So otherwise like there is small gap, so there is huge chance of connecting these two things, so it will be a mistake. I think the big one is connected to ground, no? The copper core. So like if there is small gap between the copper, this 5-volt part, and let's say this is a ground, no? So let's say there is a small gap, so there is huge chance of connecting these two. So let's say if this circuit connecting 5-volt with ground, like it will be burnt up the battery also, right? So be careful when you are designing. And other than that, I can give you a comment on your design. So try to minimize your design. Like let's say, then go to my design. All the components are dense, right? So my PCBs are, I think 7.5 centimeter and 7.5 centimeter. Width and height is 7.5 centimeters. I think when it comes to this design, like this is 10 by 10 or 12 by 12 or something. Like it will be like increasing your cost. This will be less cost, and this will be a high cost one, right? This one, because your PCB area is very big. That's what the problem, and try to like reduce the PCB area when you are designing. That's the like main thing that we are focusing PCB when designing. Actually, the component placement is not like very good looking because of, let's say, the button things to like control the medibox. So it should be aligned like this. So as very easy manner. So we should have access to those buttons very easily. And when it comes to this, let me see the 3D view. You can see, right? Buttons and buttons are here and there. So like this somewhat looks ugly. And you're naming the button name is, let's see, the button 3 name was there, and button 2 and button 1, 3, button 4 names are on top of that, and the button 3 is name is not top of the component, it's next to the component, right? So there should be a somewhat convention in there also. When it comes to my design, you can see I put all the names on one side, right? If you are accessing my PCB on this side, you should be able to read this is button 1, this is button 2, button 3, so and so, right? So try to design it like in a good manner. Yeah, it will be fine. This is your first one, no? So I am giving some comments to improve that. And here also you can like this description is very like you can let me come to capacitor 1 to our oscillators. There is like one connection, right? So we can move capacitor 1 very near to the oscillator, so we can reduce the space. So in the same way you can move this capacitor to like here, and it will be a like less length trace here, right? So try to do that. Let me see what is your bottom layer. Oh my god, there are so many connection in bottom layer. So this is not a really good thinking. So I told you like there was 2 connection in my PCB, only bottom side, right? So I told you like minimize these connections. So try to minimize this. Otherwise, there is no huge mistakes and no 90 bends, I think. Okay, good move. Keep it up. Keep it up the good work. Okay, let's move to another one. This one. Let me go to this one. Open. I think this is the best PCB we have got. Actually, we have to like appreciate him. His name is, I think, Rokshan Blaze Code is the name. Let me go to his schematic. This is looking good. This is good. Not problem. Here your power connector name was there, and let's see your other names. All the names, like it should be better in one convention. If you're naming your sub PCBs on your like in the box, you should be place your names also in the like, let's say you place your power circuit name on the right top of the corner in the box. So it's better to put this name also there, so it will be look nice. It is not a big mistake, I mean, it's a suggestion from me. Okay, that's fine. It's look good. It's better you can input any logo, your unicity logo, whatever. Like it would be a bit practice. I didn't see any logos in your PCBs. When it, right? So you can input logos into your PCBs. So I teach you how to do that. And on this, I think you can see there is no mistake, right? So all the things are aligned, no naming convention error. Yeah, this is a really good one. This is his PCB layout. You can see like this is the best one because there is no bottom layer connection, right? Even in my PCB, like there is two bottom layer connection. Like I think he had invested so many time to route that, right? So he has no connection in his bottom layer, right? So his thinking is really good. In the next level, I can tell this is a really good job. We should really appreciate you. Like this is amazing, right? So I think you have invested a lot of time on that. So this is a really great job, and you can see his like you can see some parts are thick, right? Some is thin parts. So you can see that. So the thicker parts are power line. So I told these things in my session in the last few times. So he got all these ideas. He he increased the trace width of the power lines and 3D with slowly.
Lanka, I would like to this.
You suggest.
Can you go into the laid layout? Yeah. So actually, this PCB is really good. Like about this trace width, like if you can increase the trace width in like any circumstance, like that would be the better thing, because like always when we increase the trace width, the resistance like the resistance will go low, right? So always we try to make the resistance low, and like in case like even for a signal pin, like if you can actually make the trace thick, so try to do that. So that is okay. So like our main intention is to make the like energy lines thicker, because like so those lines carry more like current. So therefore it like always need thicker lines, but like for signal lines also, if you can make it thicker, it's better, because when we are trying to when we are trying to make these PCBs, so that would be easier. Like for an example, can you tell me the thickness of that line, Dilanka, like the smallest line?
The first one is 0.25 millimeter.
All right. Yeah. So like for an example, I will talk that in my session. Like if you want to make this on your own, so you can't make a trace width less than 0.5 millimeters. So like if we change this to mils, what would happen, Dilanka? Like 0.2 mils, like uh,
Yeah,
0.2 millimeter to, yeah. So that would be 10 mils. So 10 mils is a good track width if we are manufacturing from a foreign country. But like unfortunately, like if we are like so making our own, so we would be need to increase the width. Otherwise, we can't manufacture in Sri Lanka. So that is what I wanted to convey. But a really good PCB, and like if any circumstance that you can increase the width, try to increase the width. So that is my suggestion.
yeah, I think he can increase it according to his design. It's not a big deal. This is
Yeah.
like this is 3D. This is also look nice, right? So all the resistors are in one set. Okay, this is a nice PCB. Yeah, very good job. Um, and there are so many submissions. I think the time permits now half an hour gone. Let's see, like I will be definitely giving feedbacks to everyone, because there is in your shared PCB there is a comment section there, so I can Okay, like our inspection time is over now. We allocated half an hour on time on that.
I think the Lanka got disconnected. Let me check on him really quickly. I think now he's back.
Hello.
Yeah, Dilanka.
Hello, can you hear me?
Yes, Dilanka, we can hear you.
Sorry for that. Okay, let me move to the best practices part right now. This is the first one. When you are designing your PCB, this is the schematic best practices part. I will be tell you 12 tips on there. And first one is your schematic framing. That's be a question. Like you can let's say this in our case our PCB is very small one, right? So like let's say there is a big circuit, like enough space on that. So it's better to like naming your PCB schematics, like it's better to have so many pages. Like let's say you have 10 pages in your PCBs, like 10 pages mean 10 schematics, and you can link them. I can show you one PCB like in my uh, what I have done in my uh, previous one. This is the like the PCB like I have done in my internship. Um, and this is the like we will tell tell these things hierarchical design. I'm not going through my detail about that. You can see there is in this is my top view, right? In the top view there is input. I am getting a 330 volt input, and there is some output. In between you can see there is power schematic and ESP32 schematic and relay circuit, like that. You can see this is my power circuit, this is my ESP circuit, this is my relay circuit. You can see these are the output connection and these are the input connection. So I am linking all these connection to that. Here also I named my PCB like that, P0, P1, P2, P3, like that, right? So P means page 0, page 1, page 2, like that. You can name your PCB in a this type of convention, right? So like the main thing, the main takeout message is don't like put everything in one page. Like if there is too much information on one particular page, like it should be like not a good thing to do. Like the main thing you should focus on your PCB is like you should design your schematic firing message to anyone without any prior knowledge. Like let's see, I design my PCB and I will send you my schematic, right? So I will tell about this is my like this is PDF of my schematic. So if you let's say I design my PCB and I will send you this schematic to you. So you should like when you see that, you should be able to clearly understand what I have designed, right? This is my power schematic, so you should be able to understand what is there. So what does it mean, like that? So the basic message is that yeah, let me move to the next one. Here the second big practice is schematic version, bottom right corner in here also. I told you about input some logo and give a title and input your company, dates, your name, whatever, the revision number, sheet number. The revision number is much needed thing to do if you are doing a like good design. Let's say this point is giving you schematic versioning. Versioning is this one, right? let's say this is my Medibox 1, no? So this is my first design. Let's say I will be adding another to that. So it will be a revolution. So it will be next stage. So you can add another like you can get a copy from there. You can go here and get a copy, and after getting a copy, you can add another schematic there, and you can name it as 1.1 or something, right? This kind of way you can revision it. Or otherwise, those things are almost similar. So this is a good practices if you are using a same circuit, and you should be able to revision, right? So when you are like, if there is any evolution in your circuit, yeah, like you are adding any components on there, somewhat similar to that. Okay. And the third point is power flow should draw left power flow. Like let's see our Medibox power flow. I will input my power from there, the left hand side of my schematic, right? This is my left hand. I will input my power from here. You can see power connector, and the power flow is right there. There are the output connectors, right? LCD connector is output one. USB-C is output one. So inputs are there and outputs are there. Power flow is also going here and there, here left and right, and you can see top to down. So you hello. Uh,
Yeah, Lanka, we can hear you now.
ah, did I get disconnected?
Yes, you got disconnected.
Uh, I think can you? Uh, okay. Yeah. I told you about the power flow, the 5 volt or the high connections are should be on the bottom. That's the point. Point number 3. Like you can see, like you can see, this is not a good thing, right? Ground should be on a like should be placed like this. Otherwise, it should be like it cannot understand, right? Let's say this is a transistor, so like we should be placed transistors like in a way like that. So someone can easily understand it is a like common emitter or common base or common like anything, like you should be able to understand like about from the component placement, right? That shouldn't be in the middle, it should be in the left side, and output should be in the right side. That is the message that I want to convey you. When you are designing your schematic, please like keen on these things, like it would be a best practice, right? And the fourth one is clearly show how your wires connect, right? The dots connects and crosses don't. The dot, I can tell you from my PCB. It means dot means is it's connect, like let me see here. Let's say if there is any there is no any dot, like here there is a dot, here there is no dot. No dot means there is no connection, right? You can see here there is no dot. No dot means there is no connection, like there is no connection between V in and V input and ground, right? Here you can see a dot. Dot means there is a connection. This wire connected to this capacitor, and also this wire also connected to this capacitor also, right? So this is the another thing, and please avoid the four-way intersections. Four-way intersections is this one. This is not a good thing. You can see in my picture, and this is the good thing to do, right? I told you about in the previous sessions also. When it comes to here, you can design more by this to this. This is not a good thing, right? That's why that's what I mean from that, right? You in when it is a four-way connection, you should be draw like this, right? That's the take home message for you. Let me move to the next one. Okay. Okay. Use boundary boxes to separate domains for the clear understanding. I told you about boundary boxes. In here also you can see boundary boxes. I will be show some PCBs of let me start this one. You can see this is a big PCB and you can see boundary boxes, right? So see, like, if you have a big PCB, use boundary boxes like that. So it, someone can easily understand if you separate those things and put a name over there. This is power input. This is the STM circuit. This is LED indicators, buttons, so and so. It should be a like good practice if you're doing that. And keep your text placement consistent and clean, right? So you, if you like see this picture, you can see like texts are here and there, like this is so much messy thing, right? So I some texts are even we can't read that. So this is not a good thing. I told you like when I giving the schematic feedbacks on I think in the very first one, he had done some mistakes on in naming text placement. So when you're placing text, there is please try to maintain a convention, and like you should be able to convey this schematic message to everyone like very clearly, right? So keep your text placement very consistent and very clean. This is a very clean circuit, right? Our one also, when it comes to our one, this is very clean circuit, right? Okay. The next one, always use the same symbol for the same devices. You can see when you are learning in the O level, so I think you are drawing resistor in like that, right? In a like zigzag, right? So like there are some resistors like let's see, when you go to ECDA, there is this kind of resistor as well as this resistor. So means the same thing. All of these are resistors, but their symbol is different. Symbol means the shape, right? The representation. Like you can even draw a circle on there, right? Not needed to be a box. Or if you are using a circle, so try to maintain the same symbol for entire design. That's the good practice. That's the take home message for you, right? So mark not using pins. If you are not using any pins, so try to mark cross there. In our PCB, so we mark that, right? We are not using these digital pins and analog. So we are marked cross there. So it means it mentioned that we are not using that pins. It's a good practice, right? Okay. Next point is use net labels and off-page connectors for clear schematic design. Net label means the same thing like net port, right? Net port is same thing for net label. I will be show you my another PCB. And you can see this is LTM software. Is a net, and on top of that we put a net label, right? And off-page connector is somewhat like that here. This connector is connecting to this one, right? Off page, like it's going away from a page and going in, coming into the page. Off page connectors. Like let's say you have so many pages in your PCB schematic. Let's say this is my one PCB and I have 3 pages on this PCB. So I have used off page connectors. There are so many symbols, like this is the one symbol, the mainly used symbol in LTM to indicate the off-page connector, the two symbol. You can find like if you are using LTM. In the ECDA, this is very simple software, so there is no so much advanced features. So you can try to use that. I didn't try your ECDA. The next thing is power budget. Calculate the power budget and mark ampere in traces for layout reference. So let's say when you are designing a PCB, let's say your power circuit, if you can calculate the input current and output current the IC provides, right? The input current that IC can bear and the output current that IC can maximally provide or something like that. So if you can calculate that, it's better to put a text on there by mentioning this is the current, like that, like here. I mentioning I mentioning 0.3 ampere, 0.2 ampere. It would be a good practice, so someone can easily understand what is the like electronics things over there, right? So this is a good practice, and this is the use component designators. I told about component designators. I think remember the capacitor. C. We use C for capacitors. We use R for resistors. They are resistors. Q for transistors. And I told you about buzzer. Buzzer we use LS, loudspeaker, right? LS. And there are so many connections. And U for ICs and inseparable assemblies. And there are so many conventions. So try to use those designators over like when you're naming components like here, R1, R2, R3, like that. So it will be a good practice. Yeah, the next one, name pins according to the function. Let's say like this is applicable for big PCB, like so. Let's say you have a very big PCBs with so many pages, and let's say you have a USB circuit and microcontroller circuit, and those two have two grounds, no? So let's say in your microcontroller circuit, you can name it as a let's say your USB circuit. In your USB circuit, your USB ground, you can name it as a UB underscore ground. In your another circuit, let's say whatever circuit, you can name it as a whatever name underscore ground, like that. So in the end of the day, you can connect in those things, but like for the sake of like convention, you can name it as a like separate namings with a same name convention. I use underscore, or someone can use camel case, or someone can use capitals or simples, whatever. So anyway, you should have a like you should be maintain a same convention for entire PCB, right? So that's the message I want to pass you. Yeah. Here you can see this is our one of the semester project. This is the air quality measuring and automatic ceiling fan control. There is two PCB. I think you can see the green ones are PCBs. We attach LCDs and buttons over there also. And like let's say before starting layout, designers must have clear ideas about mechanical enclosure and mounting location of the PCB, right? Let's say in my design, there is enclosure, like you can see, you should be able to see the display from here. And also you should be able to press the buttons from here, right? And you have to like, this is a ceiling fan controller. So you should be able to plug this entire enclosure to the wall. So there should be some mounting holes to like plug this thing into the wall, right? And there is a like a temperature humidity sensor, and it should be placed like that. So you should be able to have a clear idea about how your mechanical enclosure look like and how should be place my components. Let's say I design my display over there in the bottom side, like it should be not a good thing, like it looks ugly, like it should not convey a message to the anyone, right? So like you should be able to understand like and analyze what your enclosure look like and how your mounting holes, like what are the places of your mounting holes. I think you got the idea. So then only the perfect layout can be done, right? So you should be able to have a clear idea. So I had the idea about we had idea about the placement of that sensor and the buttons and display. That's why we came up with this kind of design, right? Okay. And the second point is place PCB components synchronizing with mechanical design for the perfect design. Let's say this is a drone, right? Drone PCB. In a drone, I think you have seen a drone, right? So there is 4 motors. Like there are other kind of drones also. Let's say this kind of drone, 4-motor drone, and we should have placed the motors on these holes, right? So we should have a clear understanding about the placement of mechanical like motor and all. So we should be able to we should be able to get an idea from and design according to that, right? Okay. This one. When it comes to your line layout design, place all of your edge components first and keep your parts on one layer, right? Let's say the first thing means place your all edge component first. This is the computer motherboard, right? So there is a serial input, like you are connecting your monitor or whatever things here. This is a USB input. You can connect your mouse, keyboard, and other USB pen drives also. And this is mouse connector and audio jacks also there. So those are the like output things, right? So the user should be able to access from the like outside of the computer. So that's why we place those kind of components at the edge. I think you got the idea. When you are designing a PCB, you first thing you have to do is place your edge components first, right? Like in your place, whatever edge, this edge or this edge or this edge, whatever edge, the edge as your intention, and then and after try to place other components. So when you're placing other components, like try to maintain all these parts in a one layer. Let's say you are placing these are the RAM connectors and RAM OVGA connectors, and this is a microprocessor connector. Let's say you are placing your RAM connectors over there and microprocessor over other side. Like should be like we can do, but try to mount all these components in one layer, so it will be look nice and it will be very easy for soldering also. And this is the thing I want to tell you. And when you are designing PCBs, and get PCB size shape from conceptual mechanical design. Conceptual mechanical design means we are telling these kind of things DXF files. Let me show you another interesting PCB. Yeah, this one. This is our Sri Lanka. We won a competition in challenge in 2019, I think. And this is the robot that we have made for robot PCB that we have made for that competition. You can see like these shapes are different, right? You can see there is some like here, and there's edge and over mountain holes there, and also some holes are there here and there. So this is the end output of that robot. That we design this shape first. Like you can use AutoCAD or SolidWorks, so there are many softwares to design that 2D layout. 2D layout means this edge part. You can see here, this one, like that, with the mounting holes and all. We imported that part directly. We can import that part directly for the PCB, like that. Even here also, we designed that shape separately and imported that shape into the Altia and designed on top of that, right? So you can see this is also looks nice. Okay. Let me go to my next thing. Please do layout versioning. Layout versioning means like most of the PCBs as you can dissection and see your PC or whatever things. You can see there is some version number like that V1R5 like that. There is some version number on PCBs. Like most industrial manufacturing PCBs, there are version numbers. So anyone can understand. Let's say there is let's say when it comes to the HP or Asus or whatever laptop manufacturer, like if you like dissection the laptop, you can see there if there is a PCB. Let's say there are some version, like let's say you have a laptop in 2000 and you have a laptop in 2020. Like there is a name like this is my version number and this is my date of that PCB manufacturing. Like those of things, logos and all, they have included. Layout versioning is also very important. So if you are looking into PCB, your end output, you can see, this is my 2000 output. This is my 2001 laptop. This is my 2002 laptop. Otherwise, like let's say it maybe look same, right? So you should be able to understand like what is this version, what is this PCB, like looking at the PCB, right? Okay, like you can change the revision number, like this is a convention, like you can name it as revision A, revision B, revision C, D. There is 26 characters in the English alphabet, so you can name like that. And when it comes to the A, level 1, A level 2, like that. Level means layout 1, layout 2, like that, right? So if you go into a big change, like let's say you are designing entirely separate circuit. Let's say you are using an Intel processor for your design, and another one in the next version, you want to do a same product with the separate, not an Intel manufacturer, AMD or whatever, another manufacturer. You need to do design with that. You need to come up with a different layout, right? So you should have, in that case, you should have change your name to revision A to revision B, because you are doing a big change to your PCB, right? I think you got the idea. And the next thing, make footprint library and double check footprint. I told you about footprint. Footprint is a physical appearance, like here also. Footprint. This is the footprint of the buzzer. If you turn over there is 2 pins. One is plus 5 pins and other one is ground pin. So the footprint is a physical appearance of a component, right? Basically, this is the mean. So this is the footprint of this component, and this point is make footprint library and double check footprint, like double check footprint with 3D step file. Let's say you design, right? So you should be able to double check with your 3D design. Like let's say you are buying a component, so I double check with that. You can see I imported all the 3Ds here, so I can check, like let's say I am putting a footprint. Let's say I am putting a footprint. Let's say this button footprint is very small. So like in my design, like I am getting those footprints from the internet now. So the person who designed that button footprint, he designed like in a very small rather than the actual size. So let's say I am placing like that. Like if it is a small one, I'm placing like that, no. So the actual size may be bigger than that. So definitely will be intersecting with other components. I think you got the idea. So we have to design our footprint according to the 3D design. This is very important. Otherwise, like you will be printing a PCB from a different country and importing them. And when you are going to do soldering process, you will be identified that, oh my God, this is a different component. This is this space is not enough for my component. So you will be disappointing at that time, right? So please avoid that disappointment. So to avoid that disappointment, that's what we are using. That's why we are using the PCB designing software, right? Okay, the next one. Consider manufacturing capabilities and import manufacturing design rules files into the design tools. This means by like this is the JLC PCB's manufacturing capabilities. Like every manufacturer has its capabilities. When it comes to JLC, they cannot print lower than 6 mil. 6 mil is also very small, but if you're designing a PCB less than, let's say your trace width is less than 6 mil, JLC cannot print because they have machines too. So those machines has limited capabilities. So they have some minimum requirement and minimum capacity to manufacture PCBs. Let's say when it comes to JLC, they can only manufacture up to, I think, 8-layer PCBs. If you want to design 10-layer, 20-layer PCBs, I think JLC cannot do that with their machines. That was the message I want to convey you. If you are designing a PCB and you want to print it from other company like PCB, even in Sri Lanka, there is Lanka PCB or so many companies. So you should be able to like compare those features. What are their minimum capabilities and what is their like what is the capabilities, and you have to import manufacturing design rules into the design file. Let's say this one means like that. When you are designing PCB, I told you set the rules. Here you should be able to set your rules according to that. Let's say you are designing with JLC, you should not be on go below 0.6 or 6 whatever. Like their minimum capability is 6, no. So you should not be go beyond lower than 6, right? So otherwise it cannot print. So you should be able to see what are the manufacturer's capability and set those parameters over there. So there may be manufacturer's minimum clearance. So we are diameter. So they have some drills now. So let's say you have a 1 millimeter drill, 1 millimeter drill hole, but the manufacturer don't have that 1 millimeter drill with them. So there are some constraints. So you should be able to see those things, and you have to import those things into your design, and then you have to design your PCB according to that. I think you got the idea from that. And the next one, do power budget calculation, measure the required trace width using trace width calculator. There are so many trace width calculators. If you Google in that trace width calculators, you will be getting so many calculators. And when it comes to your design, I told you, like Deepana also told you in the feedback session, when you're designing PCB, use high width traces for power lines and low width traces for like other connections. And this is also PCB trace calculator. Put a link or slides also. You can set input like you want to be a 10 ampere currents, and like let's say it will be automatically calculate the rate and other. You can set a temperature, you can set a trace length or whatever parameter. It will finally give you the trace width, right? So this is the cross section of the trace. It is like this kind of things. This width is what we are calculating. So there are so many calculators, so you can see by Googling. Please use that when you are designing PCBs, so you can design your PCBs very precisely, right? So you can minimize errors. Anyway, the next one is sketch routing. When it comes to this, also I told you about when you are designing Medibox, please do a sketch routing first. So then and after you can do your final design. When you're designing sketch routing, you should be able to identify all these connections. So what are the best connections? So what is the best path that I can travel through, right? So when you are doing sketch routing, this would be like a really good thing. Sketch routing is a much needed thing to do. So then and after you can find what are the best options. So let's say you can route here to here by going through there, right? In this path, and also you can route directly from here to here. So you should be able to identify like what is the minimum length path. So what is the easiest path. So you should be able to calculate that, so that you should be able to do you have to do sketch routing. So when you are designing sketch routing, we are like recommending to do like using 8 mil, because most of the manufacturers cannot print beyond like lower than 6 mil. So try to do sketch routing using 8 mil when you're designing. After that, you can increase your width and all that. So okay. And the next point is at copper area or solid region for power lines. I think you have included the copper area when you are going to put a copper pole in your PCB. Here, this option, copper area. If you are selecting that, it will be pop up a message like it will asking what is the layer that what is the net that we are connecting our copper pole. So we can choose ground, whatever layer. We usually choose ground for net for connecting our copper pole. That's what it asking. I think we gave in last Q&A. I gave an answer about what is the advantages of copper pole and disadvantages of all the things, and why we want to connect the copper pole to the power line or ground line. What are the advantages of that? I told about that. I think you have that idea right now. Okay. The next one is remove solder mask for a high current path. Let's say solder mask is I told you about the when it comes to the PCB. This one, the PCB looks in black color, right? So solder mask is that color. It's somewhat like a paint, right? So the PCB is basically copper board, no? And the top of that copper board, we are like putting some ink on that. Like it will be a green color, red color, like in your PCB also. Let's say this one. Let me go to the 3D design. And this is my PCB. So you can choose the board color. This is a red. This is a green. This is purple. Whatever color you can choose, this color means the solder mask. This is the solder mask, right? So my point here is remove the solder mask for a high current path. Let's say there is a big path which carrying high current. So you should be like, you should remove that solder mask from that area because after that you can like input some lead over there to like bear this current path. Um, it's a good practice. Like if you can remove that high current path solder mask, it will be a good practice. So try to do that if you are designing a very complex circuit. And the next point is use vias to remove heat. Let's say you have IC and it's heat dissipating ICs, and like it's when it comes to the working, it's get heat, right? In 7805 also getting heat. So we have to use some heat strings. So if there is no any space for heat strings, like we have to place thermal vias. Those things called thermal vias. So we are placing thermal vias with the die attached paddle. Like this is sending those heat through the vias. So this is some sort of cooling thing. So this vias used to remove the heat. I think you got the idea. And the next one, placing components using rooms. Rooms means I will tell you. When placing components while thinking electronic fundamentals. You have to think about electronic fundamentals. Don't worry, like if you are not a very electronic guy. I know most of you are not much from an electronic background. So don't think about those kind of things. So on the future slides also, there may be some electronic components, electronics theories, but don't go deeply through that. I also don't go deeply through that. So try to get the message from that. So when you are placing a bypass capacitor is let's say you are giving a power to IC. Let's say in Arduino we are giving 5 to your microcontroller. Here also you are giving 5 volt. When you're giving to the 5 volt to that IC or your microcontroller, you should be able to like use a bypass capacitor. This doing the high frequency cutting thing. Let's say in the simple terms, some sort of stabilizing thing. Let's say in your 5 volt DC current, it may be not exactly 5 volt. Like it can go here and there like 5.1, 5.4, 4.9 or something like that. It can like some sort of small deviation So this bypass capacitor means like it reduces that deviation, like it cut off those high frequency things and like small variations, right? So if you are placing that bypass capacitor, you should be able to place like very near to the IC. Like if you're placing here, let's say this is the power input, power is going directly to the IC. No point of placing that here, right? You should be able to place that bypass capacitor near to that IC. So then only it will works, right? I think you got the idea. And another thing, add ESD protection. ESD means electrostatic discharge. ESD protection chips are available on the market. If you are going to electronic shops, there are electrostatic protection chips. Like let's say you are using a pen drive, like you are designing a pen drive, you should be able to place some sort of ESD protection chip. Otherwise, your pen got damaged. Like there may be very sensitive circuits, like it will be react for very small charges, definitely. So you should be very like keen on that. Like you have to consider on that. You have to place a electrostatic discharge protection chip if you are using this, if you are designing those kind of things, like very sensitive designs, I mean, right? If you are designing very sensitive design, you should have to like look onto that, right? The next thing is let's say you have a place of mounting hole there, and around that there are some components. Let's say you are mounting hole means you put a screw on there, right? So when you are screwing that, like it will be like you are using some electronic, some mechanical tool, no, for the screwing, screwdriver or something. So or maybe you may be using some washer or something around that screw, right? So when you are using that, like it may be getting damage to other components if that mounting hole, if that components are very near to that mounting hole. Let's say in my PCB there are 4 mounting holes. Here also in the very near there is no any components on there, like you can see here also in the around that hole there is no component, so we can use mechanical tools on there, or we can use a washer over there. So you should be able to like think about that when you are designing. You have to you have to give enough space on that if you are placing a mounting hole, right? And another thing, add sufficient vias for power lines. Sufficient vias means, let's say this is a power line, right? It carrying a, let's say 5 ampere. So 5 ampere is a very good, very big current, right? And let's say if you are placing one via, not like that, one via, and your entire 5 amperes carrying through that via to another layer. Like you can see that, right? Where, like let's say in a highway, like there is only one way, let's say only one lane. So there is let's say there are 1,000 cars going through that. You can see, right? So much conjunction, right? So that's what this happens. So if you are using very high, you should be able to place sufficient vias. So you have to place so many vias to bear that current. I think you got the idea. And another thing that I want to tell you is add company logo, board names, and revision code. I told those some sort of things. You can see here, this is the micromouse robot that our team circuit breakers build for a competition in Sri Lanka. And here you can see our logos there. There is in the left hand corner, there is design in Sri Lanka with a lion. And here UOM University of Moratuwa, and we put some designation. You can see here 7.4 volts, ground 5 volts, and this is battery inputs and so many labels, right? So try to add those kind of things to your PCB, so it will be look nice, right? So try to add those things. I think I can show that PCB to you. It's Microsoft. This is our PCB. We designed everything prior to like letting print it from China. You can see, right? Okay. Let me go there. And the next one is annotation. Once the schematic is completed, reset all the designators and then re-annotate is required. Let's say this is not required for small design. Let's say you are designing a very complex, very big circuit. So there is so many components. So let's say to my design in the box, there are more components. Like let's say here I am placed R1 and here R4 is there. Like this is also not good thing. Like if R1 there, R2 should be this one. So because we flowing through to right now, R1 is there, R2 name should be there. This is not a like this. There is R3. Let's see, R2 is there. Where is R2 is there. So this should be R3 because of the flow. We are going to left to right and top to down. Leftmost resistor should be R1. Then we will found R3. This should be R2, right? So we have to name. This should be R2, and this should be R3. So there is so many components. Do that. I think you got the idea. So there is options to do that automatically. So in the LTM also there is re-annotation thing. So you can re-annotate the PCB after you design. You can just click a link and just click a button, and the button like re-annotate all the things as a content. So it's very easy for us. I think VCD also having that option. I have to see about that. And the next thing is mark all the necessary nodes, such as all the port names, especially nodes. Let's say this is a Raspberry Pi PCB, and they are placing some, this is non-disposable dustbin. There's a cross with a dustbin, and there are some other standard symbols as well. So if there is any necessary nodes like that, you have to place on the seal screen, right? In the, you know about seal screen, I told about this in yesterday's session. This is seal screen is somewhat like this white color one. Here also the circuit breakers logo and all the UOM and design in Sri Lanka stuff on the seal screen. So yeah, that's it. Let me go to the next one. And when designing, don't place vias on the pad because in the soldering process, lead will suck into that hole. Let's say you are designing a PCB, right? Like that. And there is SMD. Let's say these are resistors, and you are placing vias. Via means those kind of holes very near to that SMD pad. Let's say you are going to solder, right? You are putting a solder wire and putting getting solder iron to that, and the solder is like get a liquid state, and those solders are like not attaching to that piece. That will be going through that hole because there is a hole, no? So the lead will suck. The lead will suck into the hole, right? So there may not be a proper connection with the component because of that lead will go through that hole. So don't place like that. If you have vias, it's better to move away, right? Don't place vias very near to the pad. This is a good practice when you are designing PCB. And there is another one at test points if required. Like let's say when you are designing, the test points are very needed, much needed. If you are designing a very like let's say very marketable thing, or if you are designing a PCB to give a customer or someone else, So you have to get the responsibility, right? You should be able to see is it working properly or not. Let's say your print is, you should have to be do some testing on that. Testing. What is test point means? Test point is someone like output. So multimeter, and if you have a point after soldering process I have done, you can like place your multimeter with the test point and the ground point, and you can see whether there is exactly 5 volt or not. So that's what we are doing with test points. So when it comes to the industry, they are using several methods for testing. This is one method. We call it bread nail testing. You can see there is some sort of nails there, right? Nails there, the golden color nails. So if we putting our circuit PCB on that, it will be testing like the proper output is given or not, right? Like that. So if we are moving to the mass manufacturing, mass production, the test point is much needed thing. So if we are doing a very hobby type or very like your own product, this is not a mandatory thing. But if you are going to mass production, this is a much needed thing to do, right? Okay, this is some sort of advanced one. I will be like giving you some overview about that. And we are stitching and we are shielding to overcome EMI. EMI means electromagnetic interference. We are stitching means something like that. Let's say you are using vias to mounting hole like that. In your PCB, in your board, you can use via with the space of lambda over 8 parameter. Lambda means about wavelength. I don't go much deeper in that because there are so many A-level students as well here. So you can go through it anyway. Like if you really interested, please go through its slides. You maybe understand, or you can Google it, and you may be getting so many videos and articles. You can read and understand. So this is the basic idea. So when you are placing a VR stitching or VR shielding to overcome means to avoid the electromagnetic interference. So you should be able to place VRs in a way that lambda over 8 spaces. So that's the take home message for you. This is very advancing. I think most of you will not getting these kind of things in your in your career, like if you are not selecting electronic PCB designing as your career, right? Okay, anyway, and connect that shielding ground and normal ground using a cap. Let's say you have PCB and there is a ground in our PCB, like in the ground, we are connecting that ground to copper core. This entire red area, we are connecting our ground, right? And so let's say you want to connect that ground to your home ground. Home ground means your home electricity ground. So when you are doing that, it's better to your home ground or whatever your product's ground. Let's say your PCB is a sub part of your product. So you have to connect your ground with that your PCB. So it's better to use with a shielding ground and normal ground, use a capacitor. Uh, so that it will be a good practice. I'm not going to tell like what are the inside of these things. So I'm doing some overview, right? If someone is interested, like if anyone want to know about these things very deeply and like what does it actually happens, you can like ask it any in a Q&A session. So also we have a Facebook group like Circuit Breakers Robotics. I think you can find a link on the chat. You can go there and put your questions, as well as in our university, as well as so many people on there. I think there is nearly 2,000 members on that group. So there are so many electronic enthusiasts. So you can place your question on there, and you will be getting answers from the expert, right? So you can, yeah, you can do like that. Okay, the next one is make loop small, especially high frequency loops. This is also some sort of electronic related stuff. Let's say you are designing your PCB. Let me go to this one. Let's say you want to write here to here, route here to here, right? Not here. So you can, let's say, go a route, as well as you can go somewhat small round loop, right? Let's say this, you can create a path in a this way. The length feels very smaller than if you going through this way, right? So let's say you are designing a PCB, try to, like, if there is any loop kind of thing, any round paths, so try to minimize the length of that loop. So it will be reduce your inductance and the resistance also. So otherwise the electronics, if your path is very long, electronics have to travel through a long path. So it will be facing a lot of resistance over there, right? So it will be reducing high frequency spikes, and also another good thing is placing loop over ground plane. Try to place a loop over ground plane, so it will be further reduce the inductance. I'm not going through the in a like overview in a hierarchical way. And the next thing is it helps to reduce the amount of signals that are inductively coupled and into the node from external sources or broadcast from the node. This is something advanced thing. I'm not going to explain it here because it is a not needed thing right now. Okay, this is like, let's say if you have two lines. Let's say if you have having two connections. Let's say this one, TX and RX. Right? Not needed to be TX and RX. Let's say another things like let's say you can route the RX here to here, and let's say there is another connection, and you cannot route here to here, and you have to go through in a round path. No? If you can go here to here, so you have to go in a round way. You have to go let's say microcontroller need to process those two signals in one particular time. so in order to that, obvious this TX pin have to go in a round way. No? So you have to make your RX in the same length. Like there is small space. So how we do that? We use this snipe pattern, like you can round a pattern. You can place like that and make it the length equal, right? You can travel your electrons through that path and give the same resistance to that path. So it will be a good design. This is also advanced consideration. If you are going through the electronics field, yeah, it will be like needed for you. And also, if you have any digital and noise traces, let's say you have digital lines and noise lines, and place those things away from analog traces, because analog is like getting like it's about the what is analog means, right? I explained in the previous sessions also. When it comes to analog, it's still like it's very dynamic, right? So it will be like can get harmed by the noise signals and digital signals. So it will be better if you can place away the traces of digital and noise traces away from the analog traces. And I can show you some example from my PCB. You can see like there is an antenna. This is the ESP32 Broom chip. This product is Wi-Fi controlled relay. Wi-Fi control using Wi-Fi. We are controlling the relay module. That's what this device does. Here you can see this is
So guys, I think Lanka got disconnected again. Let's wait until he rejoins. Lanka? Lanka, can you hear me?
Yeah, can you hear me?
Yeah, I can hear you right now. I think you got disconnected again.
Yeah, sorry for that, I think. Hello. Hello.
Yes, yeah,
We can hear you. Yeah.
Okay. Okay. Can you see my screen right now?
Yeah. Now we can see it.
Okay. Okay. I told you about this is the ESP32 room chip, and I avoided the current carrying path through that, and also this is my relay module space. Here also I avoided the copper pole from that area. You can see my power path is very big, and my digital lines are very small signal carrying paths. Yeah, this is the 3D view. Okay, let's move to the another one. The next one is keep similar components in the same direction if you are using wave soldering, right? Let's say wave soldering is we cannot do in ourselves, like we have to use some machineries. This is the thing done by in industry. If you are using a wave soldering, you have to place your component according to a similar direction, right? So in this picture, you can see all the components in a similar direction on the top to down, right? Top to down, the components are placed. The direction is there, right? So here in this picture, there is no direction. The components are here and there. So there is no direction. One is on the top side, the other one is the side. So here and there. So if you are doing wave soldering, this will solder perfectly the left hand side, and the right hand side one is not soldered perfectly because the wave soldering use some sort of a thermal signal. So we put the component and solder paste on there, and we use some heat waves, and it will be automatically soldered. And it will be not a good thing if we are placing like that. So if we are placing like that, it will be not solder it very well, right? I think you got the idea from that. Another one. Add 3 fiducial marks. Fiducial marks we are using to identify the PCB, like identify the PCB direction. It is a vision system of pick and place to recognize where the PCB components assembly, like let's say machine or professional manufacturer. So they are using those fiducial marks to identify where the north and south of the PCB. Let's say you want to place like those components are placed by machines, no? So these machines use these fiducial marks to identify the PCB direction. It is a vision system. So when you are placing fiducial marks, there is a convention. So you can minimum you should be placed like that. This kind of, if you're taking someone some length as a radius, and the big one should have a radius of 2r. If you have a small r, your big pads should have a minimum of 2r. So the preferred one is 3r. I think you got the idea from that. The last one is generate 3D step files of your PCBs. 3D step file means this is the final outcome of one of the. Here also, this is our MicroMaster board. We can get the 3D file after designing. Right? We can get the 3D file after designing, so we can import this file to SolidWorks also. And this is also another PCB that we have done for our project. And this is, I told you, this is another PCB for our SLRC robotics competition. We use STM microcontroller. I have done. Right, you can export all these 3D designs, and you can view those things in SolidWorks as well. Even in your let's say your Medibox 3D views also you can import. Like, let's say go to file, and there is a export option, and you can like export anything, right? You can even export 3D design, your layout and schematic and all. Yeah, I think I have covered the best practices part. Now there is PCB manufacturing part. So Deepana will take over here. Deepana, over to you. And I have to give you a small message regarding that. In our let's say in our session plan, the last week you saw about that post. Like we are doing the in-depth microcontroller part in this part into the next week session. What is Kitminaya will do in that part. So okay.
Yeah.
Deepana, over to you.
Okay. Right. Thank you, Lanka. So I think so far we have great participation. So over 100 are like still staying with us, and in the third week, so that is really great to see. Now we are going to look at how can you manufacture the PCBs. So far we have seen on like the design aspect, and then like how we can develop that, like everything that we have like seen, right? So now we are trying to see about how we can manufacture these PCBs. So let me share my screen. Okay, I think you can see this. If you have any questions, please put in title, so I will try to answer questions. So in PCB manufacturing, so we can actually break down into two categories. So the first one can be the homemade and the basic prototype level PCBs, and then the high production level PCBs. So the main difference is that, like for an example, think that you have to develop something from scratch, and you have a very fast deadline, right? So you have to test this PCB in 1 or 2 days. So in that case, sometimes we might have the time to actually ship it to a place, like ask them to manufacture, and then to take it back from them. Like these these production level PCB manufacturing techniques. So today I about 3 techniques on how we can like how we can make a PCB in a home. So and these production level PCB part would be covered by Charlotte, and also he would tell that how can we upload a PCB and get that manufactured from a local or a foreign PCB manufacturer. So today in my part I will be covering three on how we can make a homemade PCB. So we will be like discussing about toner transfer method, the laser cutting or the laser engraving method, and also the screen printing method, right? So before I start, I would like to ask a question from you. I want to know that who have manufactured a PCB at their home, like at the moment, like have you manufactured a single PCB at home using any of these methods? So I want you all to actually reply, because I want to have an idea about how the audience is, the state of the audience. So that will help me to share like more information and go in depth if the audience knows better, or if there are like starting people, a lot of starting people in this session, then I would have to like explain it in a more brief way, and then after go into more in depth. So looks like that 82% of the 85% of the people haven't actually made a PCB at their home. But actually, like my intention is to share the whole process with you, so you can go ahead and make one. So I have done all of these 3 techniques, like transfer, laser cutting method, and the screen printing method. So from our team, we have done all those 3 techniques. So so based on that experience and the things that I will share, so I will think that you would gain an sufficient like amount of like idea on how we can do these things. So before actually moving on to in depth, there are like all of these 3 methods that I mentioned here: this toner transfer, laser cutting, and screen printing. All of the 3 methods, they have a common process. So that process can be broken down into 4 subparts. So first, actually, we should have a we should finalize the layout design, right? So before that, like we have to make the schematic, and then we have to find out the layout, and then we can do our PC manufacturing. So first, like the first step is to take a copper board and then to apply some paint on it. So in these 3 methods, like applying the paint part would be differ, right? So that is different in these 3 methods, but the concept is the same. And when applying the paint, that paint should only be applied on the part of the copper that should be kept in the PCB at last. So for an example, so let's take a PCB route. I think we like for an example in this PCB layout, this is a trace. So at the end design, this part should be remained as copper. So when we apply the paint, we need to only apply the paint in this area only, and the other parts will be removed by the next process. So that is the first process that we have to do. So in these 3 methods, the applying of paint would be different, right? And in the next, so in the next, yeah. So in the next stage, so like after we apply the paint, then we have to remove the unnecessary copper parts that are not covered by paint using chemicals. So later I will discuss the chemicals that we are using, and then we have to clean the PCB, right? So then we have to clean the PCB, including the paint that we have applied, and also the chemical that we use to remove that copper that we don't need. In the third step, after we do that also, so now we have all the copper parts, but in the components there are holes in the PCB. Like we have the VRs and we have these component holes, and there might also be the mounting holes as well. So then we have to drill holes of the components using a drill machine, or we can using a laser cutter for this. And in the 4th step, then we have to add the seal screen. And also if we can add the solder mask. So all of these 4 steps can be done by simple homemade PCB methods. So when it comes to this production level, as you can see in this photo, there are like several of these stages that need to occur. But only in homemade PCB, there are very few stages. Yeah. Next, we would be going on to see like the safety precautions that we have to take before actually learning about these methods, because safety is the #1, right? So always we should be very safe when we are doing these kinds of and like handling with these chemicals and tools, right? So there are these, I would suggest 4 things that you should actually admire and should be obedient when you are doing this. So the first thing is that at some part of the process, you will have to wear a safety goggle. So there are these 2 types of safety goggles. So the first type of safety goggle is used to actually save you from the UV light and also to safeguard you from the laser light. So that is the first kind of goggle. And then you have the second goggle is to actually safeguard you from the tools. And also there are these chemicals, like for an example, the UV chemical should not contact with your eyes. So for an example, if that UV chemical would contact with your eyes, then your eye would be really damaged and burned. So at that case, you would be able to wear these kind of goggles. And then is the like, so when you clean and dispose this chemical, you have to actually dispose them in a proper way. And the fourth is, I think like some of you try to smell everything that comes in front of you, right? But when handling with chemicals, don't try to smell or sniff that. So those are the like 4 safety measures that you should be obedient when you're trying to do this step, right? So let's first move on. So let's first move on to the first method. So the first method is the toner transfer method. So this is actually the like easiest method that you can print a PCB. So there are these several pros and cons. So I will also explain this and I have also the item. But with me, I will go through this in a very slow pace. So I have these 2 materials. So like to them, I would like to teach you how we can do it. So we have YouTube video. I will share it with you. I think I had to share the screen, optimizing for video. Right. I think you can see.
Error.
I think you can see the video, and also there's this good article that I will be also going through when I try to explain how to make this, right? So so the first thing, so this is how you like how the PCB would look like at the end. So as you can see through this method, like the accuracy is very low. Like we can't make like thin tracks and very accurate tracks using this method, but still you can do it. So the first step that we have to do is we have to get our design printed on a paper, right? So that can be done using, I think, ECEDA or any kind of software. So like if you search on Google on how to print your PCB layout, you will find it really fast. So after you get it printed on a paper, so this paper actually really matters. So when you are selecting a paper, so there are several options that we can go. So as you can see in the item list, so you can choose a art paper or a gloss photo paper. So you can find this from bookshops. So the special feature of these papers is like after they are printed, they are easy to like transfer the ink from the paper to the copper board. Like the whole concept of doing this toner transfer method is to first print that ink on the paper and then transfer the ink back to the copper board. So this art and gloss photo paper has this like effect that can be like, so that enables us to easier transfer this ink into the copper board. Right. So that is the first process, right? So then you have to cut it into a square, and then like after marking the area, so you have to cut it. So you have to cut the PCB. So to cut the PCB, there are several tools. So you can actually cut the PCB as shown in the video, or you can also use something called plastic cutter. So like some people have a different name to it. I will explain that to you in later. So like you can also buy this from bookshops. So it's not this like a normal paper cutter that we have. So that is more like harder than the paper cutter. That's called plastic cutter. Or you can cut this using a saw. Yeah. So after you cut this, so then you have to clean that copper PCB. So the reason for that is, so this is called the copper clad board. So you can also use from hardware. So from electronic shops, like in some hardware, there might be this, but I don't know whether so that is contained in every hardware, but so that can be easily found. So these copper boards, they are oxidized. So you know that copper reacts with air, and then it forms copper oxide. So in this top layer that you can see, so there's no copper. Like on top there is copper oxide. Like if you make the PCB on top of this, then it won't stick better. Like the paint that we're trying to apply won't stick very good with the surface. So therefore, you have to clean the surface. So to clean the surface, we need to have a chemical. So as you can see, they are using this high concentration alcohol. So there are like several chemicals that you can use. So one is alcohol 96%. I think you can also use. So there is this chemical called brasso. I think you have heard of it. So that is also used to actually clean the copper surfaces. So you can use brasso. And then I also contacted with some technician that has been making PCB for a long time. So then his recommendation was to use like something like Vim. So that is also okay, but actually so Vim is cost effective, but the more suitable chemical would be alcohol or brasso. So you have to clean the PCB from a chemical. And after that, you have to use a steel wool, and then this copper surface you have to scratch. Otherwise, the paint won't stick better. Right. So after you scratch the PCB, scratch the surface of the copper clad board, then you have to stick it. And make sure that you stick the printed side with the copper surface. Like if I go back, make sure to stick the printed side, not the other side. Then you have to use some masking tape and stick that stick the copper board, and then you have to take an iron. So when taking the iron, so there are these several tips that I can suggest. So the iron, most of the irons that we have in our homes is a plastic. So there's those are made from plastic. So so the problem of using plastic irons is those iron can't apply much pressure on the surface of that copper board. So then the a transfer of the ink might not happen very effectively. Like if you have this heavy metal iron, so that is good. Otherwise, then you apply some great pressure on top of this surface, otherwise it won't transfer. So put the maximum power, and then iron around 10 to 15 minutes. So in this video, it appears 10 minutes, but that is actually something that you would learn from practice. So you have to try it again and again, and then when you have the experience, so you will know the exact amount of time. So from the iron that I have, so it was around 12 minutes. So after you do this ironing part. So don't touch the PCB because that's really hot. Like after some time, after it dries out, then remove the PCB and then don't try to remove that paper part. So just put it and like immerse it in water. Like think that most of the people that who are trying to iron, they try to remove the paper without water. So then what happens is the ink will come out as well when we are trying to remove the paper. But if we use water, then it would be okay. So we would be easily able to remove the paper. But be careful when you are trying to remove the paper. Don't use something like a brush or something to remove the paper, but just use your fingers and try to remove. After that, you have to dry the PCB, and then you have to correct the defects. So as I have previously mentioned, this is the first method that you can make your PCBs at home. So because this is like the first and the easiest and the cheapest method, and there are these defects that happens when we try to make the PCB like that. Like for an example, I have explained before, like if we use 90 bends when we make the tracks and the traces, then it would really affect with these types of manufacturing methods. Then you can actually correct defects. And also, like if some track is missing, you can add that to permanent marker. So I think you can see. So he doesn't actually show how it's. So like some track is broken here. So then this track can be corrected using permanent markers. So like I was going to say, like at my first time that I was going to make a PCB, so I was very sharp deadline, right? So there was some project in our university that we had to submit tomorrow. And then at today night, I had to make a PCB. So then like what I did was, so I like at that time, I didn't even had the time to get a printout from a shop, like to iron. At that time, I just took a permanent marker and then drew the traces. So that is how I did in the first place. So I have tried all the methods, like even like all of these homemade methods, and then shipping from overseas. So we have tried all of them. So the concept is to apply some paint on the copper surface, and only on the areas that we need to keep the copper. So these are all the traces that you can see in your layout, and these the copper in this area will be stay that would remain after you etch, right? So now we are in the etching process. So etching is the term that we use to actually that is the meaning that we remove the unnecessary copper part from the copper board. So here you can see some different chemical, but like most of the time in Sri Lanka, so we will be using ferric chloride. So that is FeCl3. So I think you can the chemical reaction that happens when when we put FeC when we put a copper board to FeCl3 solution. I think reaction. So that means the copper is taken away from the board and they are converted into copper chloride. And then so that is the reaction that is happening. So from that reaction, the exposed copper area would be gone. So that is what is happening. So the chemical that they are using is different, but in our case, we will be using the more common thing that we can find is ferric chloride. So I have mentioned that. So when we are buying if someone has a problem of where can we buy these chemicals, I would suggest later, in my latest slide, I would be suggesting some places where we can buy copper these chemicals. So ferric chloride comes in two ways. So you can buy the solution that has water in it also, or you can buy the powder. So most of these professional PCB manufacturing, so these local technicians, they actually have the powder because that is very cost efficient, cost effective. So you can get the powder and then add water and dilute it to like the desired amount that you want, and then you can use. I think you are clear on that. If you have any question, yeah, can put it in the slide. Right. So then you have to put this copper board onto the solution, and after actually so that time is also dependent on the concentration of your ferric chloride solution. So that might be 10 minutes, 15 minutes, 20 minutes, but like at time to time you can like take the PCB out and see whether so whether these exposed areas like are there any left copper is there in this exposed areas. So like when all of this copper is gone, so then you can take it out. And also there's this safety measure that you have to like keep it as a mask. So you can see this person is not touching the PCB using his bare hand. So he is using some kind of a tool to check the PCB. And in case if you don't have the tool, then you have to use some gloves. As previously mentioned, you have to use some gloves. So then you have to wash it using clean water to remove the chemical, that is FeCl3, that you like that solution that is on it. So after you clean it, then what he does is, so there's this problem, right? And so I have a small question to ask from you. So you can also put in the chat. So so as you can see in this step, we have taken a printout, right? I think in the first place we have taken printout, and for this printout we have used so we have used this art paper. So my question is, what type of printer that we should use to get this printout? So my question is, what type of a printer that we use that we have to use to get this printout? So can anybody ask this, like answer this question? Right. Okay. Then most of the answers are going into laser printers. So that is an expensive printer. And some people are telling inkjet printer. Yeah, keep that answers coming. So that is really great to see. So there's another answer called laser print would be better. So have you seen that when you print from inkjet printers and like suddenly from a mistake, if you spill water on that print, like that printed paper, what would happen? Can anybody answer that too? So what would happen if you spill some water on a inkjet printed paper? What would happen? Yeah, so that is fading away. So that means like the ink that is used in inkjet printers is soluble in water. For the problem, then we can't use this for this procedure, right? So like if we use this procedure, like for the etching process, we are using FeCl3 solution, and that is like in that solution we have water too. Then that print is washed away. Therefore, like you have to definitely use a laser printer to get the printout. Then I have another question from you. So the next question would be, so now we are using a laser print, and now we have transferred this print onto the surface of the copper, right? So in this stage that I have shared, so we have like removed the copper that we don't need. Now we actually don't need the like the paint that we have put on top of the copper. So now we have to remove the paint. So how can we remove the paint? Are there any answers like some chemical? So you can name some chemical that we can use on top of like to clean it, or some other way. So can anyone suggest how can we remove this paint by using acetone? Okay, some suggest using thinner. Yeah, so great. Using very thin sandpaper. Rajiv, okay, Chatura sandpaper. So let's see what he does. So he uses this chemical, and tries, and it doesn't go away. Still not go away. Then he uses acetone. So let's see what happens. Oh, then acetone doesn't even be good. So then what he tries to do it. So you can also use a sandpaper. So you can also use the steel wool. So this steel wool can be found in many homes. So that is used for cleaning. So from a steel wool only you can clean this paint. So after that comes to the printing process. Right? Sorry. After that come to the drilling process. So you can drill using a drill machine. So there are these mini drills that you can find. So normally, so we have seen these like handheld drills that are really large, but these mini drills are really small. So you can drill these holes using a handheld drill. Sorry, this smaller drill. And then there's a question of like the drill bit size that we have to use. So for normal use, we use 0.7 millimeter drill bit, like for a simple resistors and all. Like if that is a jumper like connector or a JST connector, we use 0.8 millimeters. And for larger connectors, we might use 0.9 or 1 millimeter, like for an example, a power connector. So that depends. So you have like you might have to switch the drill bit that you're using and then drill the holes. So I really recommend you to try this at home and see actually like to see how it works. So this kind of kind of some experience that you can get to try out this. So I think you have seen the procedure. So let's get back into the slide and see the tips and tricks that we can see and like that I can suggest. So now you have the item list. I think you are okay with this. So so you have to find this, and most of the things you can find at home, and the chemicals I would suggest later on where to buy this. So the pros, like the advantages of toner transfer. So as I can tell you is, so this is the cheapest method. Like for an example, you can build a Medibox PCB for about 150 rupees if you do this by this method. And so also like the iron, I think most of you have irons in your homes, right? So you iron your clothes. Then also this is a very faster process. Like to iron, it could take 10 to 15 minutes, and to print like if you have the printout, then it is a very faster process. And also no technical knowledge is required, right? Like for the later the methods that I am going to share with you, those things like there is some technical expertise that is needed, like that is coming by the practice and by the knowledge. So for this, you don't need something like that. And about the cons, so you can't print thin tracks. Like for an example, I think in one PCB there was this track which is 6 mils. So I think if you know that, if you don't know the measure mil, so that is a thousandth of an inch, like 1/1000 inch is mil. So normally when we are designing the tracks and everything, we measure by mils. So that is like a common convention. So normally we don't measure by millimeters, we tell it by mils. So 30 mil is the recommended size if you are trying to do it by toner transfer. So like for an example, if you want a box project using toner transfer, then you have to make sure that you are like thinnest trace is greater than 30 mils, right? Then the thing is you can add a seal screen by the same method, right? You can print it, and then you can toner transfer it to the top surface by toner transfer method. But you can't add the solder mask, right? So solder mask is, I think you know, like the green color thing, or so that can be several colors. I think the Lanka really explained about that. And the problem of toner transfer method, so you can only make single layer PCBs. So like to make double layer PCB with toner transfer is really hectic process. And another con is that this is less durable and less accurate, and like it takes like more time and effort. So like compared to ordering a PCB from online, so it would be really easy to online something from like order on this PCB, but if you are trying to make it on your own, so that would be harder and more much more time and effort consuming. But as I previously mentioned, like if you are in a very hurry situation, like you want to test your circuit really fast. So then toner transfer method is one of the methods that you can actually consider, right? Right. So tips, like few tips. So you have to always clean the copper board, otherwise the transfer of ink won't happen. So I think you know from chemistry, like to transfer that ink, actually copper surface, you need this activation energy, right? So that is given by the iron, and then to actually strongly bond it to surface, the surface should be really clean. Otherwise, that bond would not happen. I think like if you have done chemistry for A levels, you know about this bonding and activation energy and everything, right? And there's like something that is really like really important when we are doing this toner transfer method. So that is like the orientation of the printed PCB. So this is really important. Like if we are doing a through hole PCB, so in our case in Medibox, we have done a through hole PCB. So that means the components we are inserting is from the other side of the PCB, and the side that we are inserting the components doesn't have any copper. So there's another method called the surface mount PCBs. So here you can see a surface mount PCB. So that is called SMD. So if you are using a surface mount PCB, so then you have to mirror the image before printing. So I think there was another question in the Q&A also, like why we use surface mount PCB. So like sometimes we need to actually reduce the spacing and the components placing, right? So that is done because like for an example, if you do this through hole PCBs, then the soldering would be done at the bottom surface. Then when we are trying to mount the PCB, then these solder points would be touched with the enclosure, and sometimes it is hard to level. And if we try to place all the components and everything on the copper layer, so then the other side would be just flat, and it is very easy to handle. So that is why people go for the surface mount PCBs, right? And the ironing time you have to master on your own. And when washing the copper, so when washing the copper board, please be careful to remove the art paper by hand. And if you see some broken tracks or anything, just clean it by a permanent marker. And also make sure to use gloves when using ferric chloride. Otherwise, your hand would get injured, and it would be in a bad color. So I think you don't want to get your hand injured or seeing it in a bad color, right? Okay. I think now you are okay with it. And I have this article that I wanted to share with you. So there's this PCB test CAD design. So you can actually check whether your PCB manufacturing method is accurate by just printing this, printing this and etching this, and then you can actually measure like how accurate your PCB manufacturing method is. So you can try it. So print it and iron it, and try whether see whether it's okay. And also the cutting PCBs. So there is this tool called separate cutter, but these are harder to get in Sri Lanka. But you can just use a plastic cutter. So then they have used several types of chemicals and seen how effective is the chemicals to clean the surface of the copper board. So as I previously mentioned, most recommended ones are acids like HCl or alcohol high concentration, but you can also use something like Brasso. So let's move on to the next method. So this is called the laser cutting method. So this is also this more accurate than the toner transfer, but it's not really accurate enough for more complex PCBs. So but let's try. Let's see how we can do this. So I have another video to walk you through this, because because of this COVID restrictions, we are not able to show it in a live way. Yes. Open this. Let's go through this video and see how we can do this. So if anyone doesn't know what is a laser cutter, so a laser laser rays are something that is really powerful. So laser is actually a visible light that is concentrated onto some particular area. So I think so like how powerful is light, right? So you have done this practical where you use this magnifier and then concentrate this light onto a paper, and then like after a few seconds or minutes that paper get burned, right? So that is the same analogy that is used in laser. But lasers are like specially produced that you like having the same phase and the same speed, like so the speed is same in every IR or every electromagnetic wave, but like so those are created separately with the same phase and everything. So that like so those ways are really powerful. So we can cut boards, or we can engrave on boards. So engraving is a procedure where you make marks on a board. So normally those are done on wood, and we can also use the do that on PCBs. So let's see how we do it. So as first, so so actually, when we are using this laser cutting method, so I really recommend to put a copper core. So I would then later discuss why that we need to do it. Yeah. So here they have used this. Okay. So like in this example, they are not using a copper core, but I really recommend it. So let's see why we like why is that later. So you can so actually like so this step you might not be able to do it by your own, right? Like if you have a laser engrave at your home, then it's really good to have that. But I think most of us don't have a laser engrave at our home, so those are really expensive. Sometimes they might cost more than 1 lakh. So so most of the time we don't have that in our homes. So in that case, we have to go to a laser cutting shop and then get it done. So like tell them that you want to have a laser engrave and give the design. So then they will add it to their design software. Let's add. So take this PCB and always clean. Like in every case, we are transferring some ink. Like that is the procedure. So for this, what we like in the later like in the earlier method, we have transferred the ink with like only to the areas that it had the tracks, right? So in that case, we do it directly. But in this laser cutting method, what we do is we apply paint on the whole copper board, and then we remove the areas that we don't need. So that is what we do. Let's see how. And always, so this is recommended by like a technician that I really know very closely, and I think you will get to know who is the technician, like person in our workshop in Charlotte sites. So like, over time, when you are cleaning the PCB, don't clean the whole PCB. Just clean the part that you want to your PCB. Like just cut the cut the copper board that you need to your size, and then clean that part only. So this is the cleaning process, and then you have to spray some paint on that part, and that paint should be uniform. Right? You should not see any defects, or like some parts are more higher than the other parts. So to paint it uniformly. And about the paint, so so you can use any spray paint, like in any color, that is okay. So here they have used the blue color, and then they have imported this to your engrave machine. I think this is not a part that you would need to do. So that would be done by the person that is in the laser cutting job. Right. So after adding to that, then as you can see, this laser goes through the design, and then like engraving is done on the areas that should be removed. So you can see the areas that should be removed would be burned by the laser. Right. Okay. Then so now I have another question, so you can put it in the chat. So my question is, what happens when these parts are getting burned by the laser? What would happen? Why do you think that we have done something like this? If someone can answer, that is really good. So we have painted the surface, and then we have burned some parts that we want to remove. So what would happen when we burn that paint? Can anyone answer, or is it a really hard question? I don't see answers coming up. Yeah, that's okay. It will melt. Melt vaporizers. There are several answers. Okay, really good to see the answers. So thank you very much for that, Sajjana, Ranjeev, and Ravindu. So let's see what happens. So then he uses this small brush, and then cleans the part and removes the paint, and only the paint that is exposed to the laser would go. So the reason for that is, like a normal spray paint that we purchase from the hardware, so those are not soluble in the water, and the paint that is exposed to the laser, and that paint would go when we brush with water, actually using a brush. So that is so that is the idea behind that. I think you understand that. So these are like a real practical stuff that you can like understand and do if you are really interested in it. So now you can see only the area that we need to have copper would have the paint, and that won't be soluble in water. Like in the first case, like that laser cutting ink is not also soluble in water, but like if we use like a steel wool, then it would go. But like even though we use a brush, that paint won't go. Right? So that is the difference in this process. So after this, I think you know the process. So you use a ferric chloride solution, and then you put it into the solution, and then after etching, so you put it and keep the time. So here they use gloves. So that is really good to see. Don't touch that chemical with your hands. Right. So then you have to wash it and remove the chemical. That means FeCl3. You remove that excess amount of chemical. Then you can see a very clean board. Yeah. So this person uses laser cutting to actually cut the PCB board shape as well. So that is really easy. Otherwise, you can't cut very specific parts now. I have another question. So this is really interesting. So what would happen if you try to cut a copper board directly from a laser cutter? So that means now this like now this area that he's trying to cut doesn't have copper, right? So earlier it had copper. So what if he tries to cut this PCB like to a desired shape when the copper is there? What would happen? That's another question. Let's see who can answer this. Okay. Okay, reflecting. So that is true. Thank you for the answers. So copper reflects this laser rays. So that means you can't cut the copper board like if that has copper on it. So that is why we cut the copper board after etching. Like so, when we are doing this production, production level manufacturing, they won't cut the PCB using laser. So they use something called a CNC cutter. So using that, they are cutting using a tool, right? And not through laser. But in this laser cutting process, like after etching, you can even cut the holes, right? Even the PCB board and everything, right? So, yeah. So now, like the same question. So they will be using several chemicals in this as well. So what do you think is the chemical that can be used to remove this paint? So earlier, the same question was there. What type of chemical that we can use to remove this paint applied? Like these are really practical questions. I think like you can, you might be interested in answering this. Tina, okay. Are there any more answers? Turpentine. I think both are closer answers, but yeah, great, thank you very much. So as you can see, they are using they are using acetone. So this acetone is more concentrate, like has more concentration than thinner and turpentine. But you can also use those chemicals as well, but like those are not like high concent, like those doesn't have that concentration enough to remove that chemical really fast. So using acetone, you can very easily remove. And so now you might be thinking, where can I buy acetone? So that could be also shared in the later slide. So by using acetone, you can really easily remove. So now you can see, like compared to the toner transfer method, so you can make a good PCB using this laser cutting method, and it is easy because you are not doing the ironing process. So you have to take it to some laser cutting shop and then do it, and using a small chemical, you can remove that, right? So you don't have to brush, right? Do anything like that. Right. So that is the process of laser cutting. I think you can see. Let's get back to slides. So so talking about the laser cutting, so that is a fast process, but it's not like really fast like toner transfer, because you have to engrave, and this engraving process is like takes much time, and that time actually that time is based on the copper area that you have to remove, right? So that is why I suggested to use a copper pour. So using a copper pour, you can reduce the you can reduce the copper area that should be removed, right? That needs to be removed. So therefore, by using using a copper pour, you can reduce the time to manufacture. And for this, also you don't you don't need to have any technical knowledge, but you have to go to a like shop to get it engraved, and it is less effort than toner transfer method. And also you can't print tracks that are less than 20 meters. So that means 0.5 centimeters is the margin. So you can't print less than that. And no seal screen and legend like in toner transfer. So you could print the legend using the same method, but in laser cutting you can't. right? But you can engrave, but it's not very professional. So double layer PCBs is possible if you have the correct placement. Like for an example, after you print the PCB like that, so then you put the other part up and do the same thing. You can print a double side PCB as well. So in double side PCBs, there is something called vias, right? So these vias are used to connect the two layers together, right? So they are a connection that goes from the first layer and then to the bottom layer and then routes in that way. In that case, if we are doing this PCBs in home in these methods, so we have to manually connect this top and bottom layer vias using like some kind of a string or some kind of some wire. So we have to manually connect. So that is the problem, but double layer is possible, and the cost is and the cost might be a bit high because we are laser cutting and laser engraving, and the same thing applies to this as well. So you have to clean copper code, that is really important. And about the mirroring, and compared to this, so I have mentioned this as if you are using through hole components, you don't have to mirror the layout, but if you are using SMD components like this, you have to mirror the layout. And here what it does is considering a double layer PCB, that at the top layer you don't have to mirror, but the bottom layer you have, otherwise you might not get a good design. And also when engraving, you have to keep the PCB really flat, otherwise it won't engrave every part of the paint at the same level, and the paint should be applied uniformly, and the same thing using the gloves, right? I think you now have a good idea. So you can refer to this one if you want to know more about this, right? So you paint it, and like that you have all the process of how you can do it at in an article. So you can refer to that. So now we are going to the final method. These are homemade. The reason I mentioned these are homemade methods is the process is not really complex compared to something like this. In this we can see like very high number of processes, but in homemade methods there are very things, right? And when we move on to this, is the most complex method of making the PCB at home, but this can be outsourced to someone like a technician that has good a good experience and expertise, right? But the thing is, if you want to master this technique, it's really hard. It would take time, and the starting cost is really high as well. When I had a chat with him, and then I actually took I took this item list, and then I figured out the initial cost that is involved with making a PCB in this method. So that can be gone up to 8,000 or to 10,000 to start. So that means to make your first PCB at home, if you want to buy everything from scratch, all the tools and everything, you would actually have to invest around 8,000 to 10,000. But after that, to make a single PCB is really cheap. So that is around 200. For the Medibox project, it would be around 250 to 200 rupees to manufacture it in this way. So if you want to make it if you want to print 10-15 PCBs, this method is really good and accurate method. So let's see how we can do this. So before I go into this, I have another question. So I like to ask a question from you because I think it's interactive. So can you put some answers on the areas of fields that screen printing is used? So one example would be to print PCBs, but I want you to come up with other examples where the screen printing technique is used. So screen printing is a is a defined technique that is used in several industries. Printing clothes, banners. Are there any more answers? Mugs, advertising, cloth printing. So of course, in t-shirt printing, they are using screen printing methods. Actually, like the t-shirt that I am wearing, they haven't used screen printing, so they have just like sewed this logo. But in some t-shirts, I think like in casual t-shirts, you can see this like several patterns that are printed on the t-shirt. So those are printed using screen printing. But for mugs and advertising, they don't use screen printing because that is really expensive. But they have like separate printers to do this. Right. But like in mug printing also, they are doing this toner transfer method. I think you have seen this. So we can print we can print the design in paper, and then we add that into the mug printing device, and then we heat it, right? So then it get the activation energy, and then the ink transfer onto the mug. So that is how it does. But in screen printing, it's a separate method. So let's see how it does. So this is definitely using a t-shirt printing, and also in PCB printing, and also this is using for printing printing on enclosures. Like for an example, printing on steel surfaces. So we can use same screen printing techniques. Like for an example, if we have a steel enclosure and we need to print something on black or white on that steel enclosure, and we can use same screen printing method to print that. I think you now have a sound idea on this screen printing methods, right? So let's see how we can actually so this screen printing involves in two kinds of processor. So the first thing is to make a screen. So like here you can see the screen. So even into print your first PCB, you need to make a screen, and when you have the screen, then you can go on printing like multiple PCBs with the same screen. So that so then it's really easy. But first you have to make a screen. So let's see how to make a screen.
Today we are sharing you about making a printed circuit.
I think this one.
So design.
So see that so in this here these are printed using screen printing. I can't actually catch that frame. So it's like so that frame is harder to catch, but so this black color enclosure they have printed using white ink. So that I think you have seen, right? So also you can print this ink using like print on copper boards as well.
So let's move to the video. There are two stages for screen printing: screen making, screen printing. Materials required for the whole process are custom-made exposure mode, ready-made.
This is called a light box. I would explain when it goes in the video. So you can make a custom light box like this in your home, and this is called a screen, right? On the so actually, like even though we tell this as a very technical name, this is a very simple thing. So you can make a frame using 4 wood pieces, and then you can attach the neck. So like the net means the mesh on top of it using a glue gun, or you can mount it using screws.
Screen, water sprayer, reducer, photo emulsion, screen squeezer, butter paper, PVC ink, ammonium dichromate. This material
So actually, I will explain about these chemicals. So you would need a screen like I explained earlier, and then you need this like to create the screen. You would need something called photo emulsion ink. Photo emulsion ink is something that you know, like I need to create a screen. And like as I promised you earlier, these everything can be purchased from these shops. Like there's a separate street in Peta that is called Bangshal Street. So in Sinhala, it is called Bangasala Mawata. So you can go there, and they are like they have several shops. So one shop is the Imperial. So I have linked to their website, and there's another one called Glowchem. So in these shops, you can buy the chemicals a really cheaper price. And there's this another one, I think it's in Kottava or some area. So that is called Nelus. So you can also buy like everything at the squeegee, this frame and the mesh and everything you can buy from there. And the photo emulsion ink and everything you can buy from these shops. Let's see.
Around 500 rupees. First of all, mix photo emulsion and ammonium dichromate.
Like even like in this video, they have already made this frame. So like and applied the mesh. And when actually buying the mesh, so there are this specification of a mesh that is defined as holes per square centimeter. So this mesh actually has holes, and when we apply a water on top of it, so from the other side that water is coming out. So that means it has holes. So like to screen printing techniques, so we have to actually select a mesh that is between 100 to 120 square, like 100 to 120 holes per square meter. So that is the mesh that you have to buy. So for a screen print, like so for a printing on t-shirts, that that specification might be different. So that you have to select from depending on your application.
10:1 ratio. Ammonium dichromate.
So
Here
like
we are using.
so when we are doing it in Sri Lanka, we don't need to buy this like ammonium dichromate. We only have to buy this UV emulsion ink. So that is
Photo emulsion
enough.
of GG Photocode brand. Ammonium dichromate.
Therefore, this part is not important.
And photo. Let us.
Right. So after like so in this case, like they also explain it in the video. So when applying this photo emulsion ink, so that ink is really sensitive to sunlight. So therefore, actually make that room like a full dark before applying the ink. Like in this video, they are like so they haven't turned off the lights because like otherwise we can't see what's happening. So that is the reason. But when you're doing it, please turn off all the lights.
Now, let us squeeze the solution on both sides of the screen using a squeezer.
Right. So to apply this paint on the screen frame, we are using some tool called other squeegee. So as you can see in this photo as well. And there's this another tool called a quarter. Quarter. So by using a quarter, you can like even apply this even easier, but that would be higher price. You have to you have to apply this in both sides.
The solution. The screen will dry in almost 10 minutes. Using a heat gun or hair dryer, we can dry the solution.
Yeah. Then you have to dry this using a heat gun, or you can keep it at some place.
Faster. Using a heat gun, try not to concentrate on the same area of the screen as it can damage the screen. Here we have used some lights for getting a clear video. This process should be done in a dark room.
As they say, we have to do this in a darker room.
Let us print the required design on butter paper using a laser jet printer.
Yeah. So they say it has a butter paper, so like we can get this paper asking as a tracy paper from the hardware. from we can ask it from a bookshop.
Using a laserjet printer. Keep the printed butter paper on the top of the light exposing unit and then place the screen above it. In order to get a better between the screen and the butter paper, we can add some over it. You can easily make this exposing unit using a bucket.
So this unit is called a light box, and we can make it our own or we can purchase it. But if we are trying to purchase it, it would cost a lot. And so what happens is that, like, here the concept is so when this ink is when this photo emulsion ink is exposed to UV or some kind of like so sunlight of course has UV, and these tube lights, that means these fluorescent lights, they also have UV, but LED has a less amount of UV compared to other ones. So like the concept is, if we expose this surface to UV, then it would become dense. So then that part won't be solvable in water. So that is the concept.
And a round LED bulb. Keep it for 6 minutes to expose the screen.
So they say 6 minutes, but like when I asked from when I asked from our lab technician, so he stated that so that depends on the light that we are using. Like for an example, if we use a CFL bulb or a bulb or a tube light, then we might need to expose it around 5 to 6 minutes. But like if we are using direct UV light, then we won't need to expose that far. Like 30 to 40 seconds might be enough. So that is his suggestion.
Let us wash exposed screen using a sprayer.
Right. So after you expose, then the areas that should be printed. So in this, like the thing is inverted. So earlier we have done is like we want to keep the paint. We want to keep the paint on the areas that we need, and then we want to remove the areas that we don't need, right? But here, like in the screen, we have to remove the areas that we need, that the paint should be applied on the PCB. So by spraying with a spray, so normally like people use a spray gun, some fast spray gun, and then then these areas will be removed. But don't try to touch this this mesh, so to brush this mesh. So if you do it, then the mesh will be damaged, and the printed shape would be faded. So you have to use a spray gun to remove the
Try the screen for printing.
And then you are okay with the screen.
Our screen is ready. Let's move to the screen printing process. Here we are
right. Like after you make the screen, now you have to print. So that is the second process that you have to print, right? So now you have the screen with your image that you want to print, and then you have the next process is to print. So that I have a separate video.
Board using screen printing in a post-on application.
So as this video says, there are 3 parts. So the first part is to make the track, and then we can print the legend. So they say it has a legend, so we say it has the silk screen, and then we can print the solder mask. So here in this case, they print it in green.
The materials required for the process are exposed screen, circuit board, solder resist screen, reducer, ferric chloride, catalyst, copper clapboard, squeezer.
Right. So now I also have a small question from you. So can anyone guess the ink that we are using here? Can anyone does anyone know the ink that we are using for screen printing? So in the previous techniques, we have met like several kinds of things. So we have used a spraying to like a spray paint for laser cutting, and for a toner transfer, we use the toner that is coming in the laser prints. For here, what is the print what is the type of ink that we are using here? If anyone can guess, can anyone guess that? Sajana has mentioned emulsion, and has mentioned emulsion used like studies used when creating the frame. So that means the screen. So after actually creating the screen, we will be using a PVC ink, like as mentioned in the slides. We will be using a PVC ink. So the importance of using PVC ink is, so that ink is dense and it actually not fades away when printed. So from that it is easier to etch. So we will be using a PVC ink. So this is the this is not the ink that we use for screen printing on T-shirts. So that is a separate ink. So but for screen printing on PCBs, we are using PVC ink. I think you are okay with that.
Catalyst, copper clad board, squeezer. Now we can start the process. First, we need to clean the copper clad plate.
As always, we had to clean the copper.
Butter
That is something normal, like
This
dry.
we need to be printed. First one circuit, second one green masking.
Like here also, we have to like really consider about this mirroring when printing the design. So I would like to tell it to you beforehand. Like for an example, if it is a single layer PCB and the components that you are using is through hole, you have to mirror the design. And if it is SMD, you don't have to mirror. And in double layer, like everything that is printed on the top layer, you don't need to mirror. But if something is printed on the bottom layer, you have to mirror. Like for an example, the seal screen, the solder mask, and the top layer, actually you don't have to mirror. But the things that are printed in the bottom layer, so that means the solder mask on the bottom layer, and the bottom layer actually like the copper layer, we have to mirror.
Third one lesson. If you are
So to save time, they have actually created the screen using all three designs. So that is like really easy. And when we are printing some part, we have to cover the other parts to secure them. So we can print them that part later.
channel, and you want to know how to make a screen of a Sequan 420. In order to print all boards in same registration, we can fix the board with the help of a double-side tape on table for getting a equal alignment. First, we are going to print the track by using the circuit blue ink. For that, we need to dilute the ink using the reducer. Circuit blue ink is a premium quality ink, so we can print very narrow track in a precise manner by using this. In order to prevent the spreading of ink to other areas of screen, we must close it by using a paper masking tape. Next, we are printing the track on the PCB. And we completed it. By using this method, we can print up to 50 boards per minute.
As you can see, this procedure is really easy to print after you make the screen. So the harder process is to make the screen. So most of the cost that is involved in actually screen printing PCBs is the part to make the screen. Right after you make the screen, then it is easy to print. Like that is why I mentioned that if you make the screen, then you can print like several PCBs really fast, like 100 or 500, or you can even print that higher quantity as well.
After doing the printing process,
you need to clean the screen using
right? So like if I go back to how these are printed,
up to
so we have
15
to
holes
like
per
apply
minute.
the PVC ink on top of that, and then we have to use the this squeegee to apply it on the PCB. And like sometimes like some of you might be wondering then how actually this ink is getting into the other side. So as I previously mentioned, this is a mesh. So this has holes, right? So from these holes, some ink can go to the other side. But then there's a problem. Then you might ask, the whole ink can go to other side, and then the design won't be there. But we have created this design by using that UV photoemulsion ink. So from the ink, like the parts that has the ink actually doesn't let the other inks to go through to grow through them. So that is the reason that this screen print actually works. So the areas that are not covered from this photo emulsion ink are the places that can the photo emulsion ink. I think you are clear on that.
After doing the printing process,
Then you have to
need
clean
the screen
for
using cotton waste
later use.
reducer so that you can reuse it for other printing processes. In order to get the track visible, we need to wash the board in a solution which is prepared by.
Now now we have printed, and then like we can inspect whether there are these broken tracks and all, and then we can fix them using permanent marker.
Mixing water,
and then they are using the same process
the board
to clean the
we'll be able to get track
using FACL3.
10 minutes. For making the process for your safety,
So in this
chloride
video, so they are touching this from their hands, but actually don't do this. So they are also telling not to do this in their videos. So but these are Indian guys, so they don't think about their health. I don't
as per
know.
the requirement. For your safety, we advise clean them. Later, using the scrubber.
Then you have to wash
we
through
need to
water.
remove the ink above the tracks, and thus we printed the tracks.
So here also, as you can see, like to remove the ink, you can use the steel wool as we have done in the toner transfer, right? But in laser cutting, we have used acetone.
Remove the ink.
Now you can.
The tracks.
I think you are clear with the process.
Thus, we printed the tracks on the board. Legend printing. For the process of legend printing.
So the same the same thing goes for the legend printing as well. And also like even for the previous process, you can use the same ink. So normally at the PCB printing people, they use the same ink because the ink that is used for in the copper layers, we are removing that. So in that case, we can use the same white ink for that as well.
We need to dilute the PVC ink with the reducer. The legend printing is very useful for the component insertion.
So now they have printed the steel screen. They have to print the mask.
We need to mix the solder resistor greening.
Right. So now I have another question. Can anyone guess the reason for using a solder mask? I think Lanka has already answered that. Can anyone post the reason why we use a solder mask? Madhusha is telling prevent oxidizing. So that's the answer. So we have cleaned the PCB using, I think, using an alcohol, right? Alcohol or an acid. So after that, we are doing this process. But later, so when we go ahead, the exposed copper traces are also decaying with oxidize. And it makes the copper oxide. So to prevent this from oxidizing, we apply the solder mask, right? So that is done in this process.
And catalyst.
So for this, we can't use the PVC ink. So there is like separate ink for.
And after this,
this solder mask
solution with help of a reducer. After doing the screen,
So the same process
precision,
apply to
ink
this.
to
So
the
then you
ink
can
process.
apply the solder mask as
It
well.
will take almost an hour for the ink to get
Then you have to
dry.
dry it.
And thus we completed the printing process of our PCB. And after building the component code and assembling the component, we can use this for our purpose. Thanks for watching our video.
I think now you have a good idea about that, and also I have to share one more thing. So as you can see, like with screen printing method, you can make all these three things, like the solder mask and the silk screen, like everything, right? But like in some cases, we might not have these like inks to have this solder mask, right? Like for an example, in this laser cutting and this toner transfer method. So does anyone know like some alternative to protect this copper layer to prevent it from getting oxidized? Does anyone know some method that we can use to protect the copper layer from getting oxidized other than using a solder mask? So this is actually some method that is like found by these technical people like in Sri Lanka to use it really easily. So this Ravinda has given the exact answer. So there's this thing called Rata Dummala. I think that is a Sinhala word. I don't know what is the English word for this. So we can get some Rata Dummala and we can add it to Petra, and then we can make a small solution, and then so from a brush we can apply it on the copper layer. So then it would prevent it from getting oxidized. So that is some method used locally to prevent it. Right. So let's finally, as a final part, I would go in the tips and then I would hand on to Shaklutha. So as you can see, so this is the highest accurate and durable method in like homemade PCB manufacturing methods. And here they also have this constraint. So you can't print tracks that are thinner than 20 mils, and also a clearance should be 0.7 millimeters. Like for an example, like Charlotte, I would mention you like a couple of manufacturing methods, and there is this Sri Lankan method that you can use. And in that, like if you are like trying to print with him, like please make sure that you use these constraints when you are building, when you are getting a PCB manufactured. So those are the like several things, and so going on the tips. Do not like apply excess amount of paint on the screen. So that would actually apply more paint on your PCB. So that that would actually fade the colors when we are trying to remove the screen from the copper board. And also do not over expose the photo emulsion ink light before exposing to UV light. And then you have to properly clean the screen after use every time. So those are the three methods that are discussed that are like homemade methods. Like my recommendation is to like if you can try this toner transfer method at home, it would be good, but do it at your own risk. So that is like something good to have an experience. So we have done all of these three methods. Like in our semester, so in our second semester, we had this semester module where we had to screen print a PCB. So in those days, we have I think tried more than 10 or 15 times to make a screen printed PCB, and finally we were successful. And this toner transfer method also I have done for several PCBs when I had to do it very fast. But these production level PCBs are also cheaper, very cheaper, but they actually take time, at least 2 to 3 days. And if you try to get them from overseas, they would actually take more time. So that is the difference thing. And if anyone is willing to to the screen printing methods, try to contact us. So like we can also guide you, and we have our like people that like knows it better. So this method is even easier than component transfer, but it would cost more. So that is it, and I would handle to Charlotte to tell you about how we can manufacture them by outsourcing it to some local or other foreign manufacturer. Over to you, Charlotte.
Yeah, thank you, Deepana. Like, I think before moving into my session, like, it's better like if we have a Q&A session. Like, I think since Lanka, Deepana, I also hear like we can do a Q&A, right?
Yeah.
Yeah, we can answer some questions.
Right. So let me share.
Sure.
Right. Okay. I think you can see. Right. I think there's a question on chat. Can't we use dry fill method to make PCBs at home? Yes, you can use dry fill method. Actually, so that is using that is being used in most of these production level PCB manufacturing. So that is better. Like if you can try, but I didn't include that in this processes because I felt that like in Sri Lanka we can't find all of these materials in home. So that is why I didn't actually mention it. But so I think Charlotte will go through like how JLC is doing this PC manufacturing. So in this session, like in this process, they have a separate thing called dry fill manufacturing. You can also learn about that in that.
Yeah. I think Deepan, you can take the first question, right? Laser cutting thing.
Right. So most of the laser cutting shops, they won't spray paint on your copper board. Like most of the time, you have to take a PCB and you have to cut it and clean it, and you have to spray paint. But there might be some laser cutting like shops that do this, but normally these like these laser cutting shops so their services are based more on like other like kind of services like engraving on wood and cutting others like kinds of materials. So they are not normally focused on making PCBs. So in that case, you might need to apply paint and cut it and everything by yourself and then go to the shop. I think I answered your question.
Yeah, I will take the next one. What is the reason we shouldn't have 4 connection at a single point? You mean that 4-way connections? Like I explained that reasons also. I will explain again. All right. In the 4-way connection, that there is no rule like you should like make 4-way connections. I think I can share my slides.
Wait, I will stop.
All right. Here 4-way connections is like that, right? He's asking why can't design like that. Actually, you can, and the design is also similar. Like this, if you design like this, or if you design like this, those things are similar. But like it is really good. Like if you design like this, like not connecting like that, because like someone can understand clearly if he's seen like this kind of connection rather than this. That's why we are suggesting like this is a good practices, best practice. The best practice is designing like that, not like that. So anyway, if you want, you can do this thing, but we are recommending this to do. There is no any strict like rules or like of thing, but all the things that I have shared today is the best practices. Like it will be good for you, good for your future, and like that.
And also, I would
Deepan,
like
think
to
you
add
can share
something to
yours.
that, Dilan. Shall I add?
Yeah.
Yeah.
Sure.
So that like 4-way connections is applied to schematic only, right? So like for layout, you can add like 4-way connections, like even to a pin. But in schematics, like as the Lanka shown, like sometimes we might be confused that whether these connections are connected together or not. That is the case that we recommended not to use four-way connections. So let me share. Right. Okay.
Yeah, so like we can provide you with some
Yeah,
materials
I'll,
like yeah.
I will put a link in the
thing
chat.
is, yeah, I think it's better like you can start learning those theories like that's where you can like get the maximum out from this PCB design. Like if you are designing a PCB with your electronic knowledge, that's the better option. Like without having those knowledge, you might have to face some issues. But with your knowledge, you know what is if certain issue pops up, you know what is the problem and what should be the solution to that. And regarding if the ironing time depends on the iron, is there a way to check if it's completed? Usually, actually, this kinds of depends on the iron. To be honest, that's why, like in Deepan also mentioned that those things are come to familiarize with you guys while you're doing those things. Like they comes with the experience, and you know, like if you like iron it for too long, then the like those. What it said, like those things will be kind of stitched into your PCB board, and then it will be very hard to like it will then damage your PCB tracks as well. So it should be like kind of comes with your experience actually, and also it depends on the iron as well.
Yeah, and I would also like to add something to what Charlotte said. So I also agree with Charlotte, and so like if we keep this iron for long, then the copper layer would detach from the copper board. So then like it would you can see these kind of spots that are lifted from the PCB surface. So I don't iron for too long. Like if you use a plastic iron, you might need to apply more pressure, right, Dilanka? I think
yeah,
has more experience in that.
Yeah, there are two categories of iron in Sri Lanka. I saw someone very heavy. It's made of full of iron, metal, and other one is most of the irons are like plastic kind of irons these days. When you go to shop to buy an iron, like you will be buying a plastic kind of iron, and it is very less in weight, right? So if you're using that kind of iron, like you have to do some manual pressure on your PCB. So then it will make sure like your PCB will make with the copper layer. And also when it comes to the iron, like there is specific point that it will come out. Like you can see what is iron inside the mechanism of that iron. There is two metal layer and one will go I'm not going to explain those things, but when it comes to the iron, there is a one particular place like the heat comes from. So you should be able to move iron let's say after 5 minutes. Some sort of things are getting done, but maybe the edges of the PCB not trace clearly, but then you have to move your iron for the edges and spread the heat on the edges sides of the PCB and make sure these toners are transferred to the paths are transferred to the PCB. So I think that's came with the experience. So that's we had our experience. So definitely you have to do your own and get the experience. So by the experience you can check whether it's completed or whether it's done or not. But typically you have to spend ironing between 10 minutes to 15 minutes. That's the margin we are suggesting. So anyway, you have to do it by your experience.
And for the next part, I think in the next session we are trying to plan to have this at the beginning, like after we manufacture the PCB and after we have assembled, how can we upload the PCB? How can we upload the code to the PCB that we have made? So we have programmed this using Arduino. So we can't just upload like the code directly. Then we have to upload the bootloader first and then the code. So that would also, we are trying to arrange that in the next session, hopefully.
Yeah, and also like regarding the PCB, like we have already designed it. Like in my session, I will show it to you guys as well. So what it is look like in real life.
Great. I think Lanka it's up to.
Yeah. He's asking what is the tool that we should import from ECDA library to have a DC power input socket. So I gave my library to all of you. You can simply go ecda.com/blankal/component. I gave the links previous day. I think there are more than 150 people gone there and they got the libraries from mine. I included that power socket. I use JST power socket. You can use any power socket like there are in the electronic shop. There are some sort of like connecting wire. Like you have to input that wire and there is a screw and you can like by screwing you can get tighten the wire. So there are those kind of connectors as well. You can use any connector for that for the power input. Yeah.
Then there's the question about 3D printing. So I have also given a reply, I think, to him. So so you can go to our website and then upload the like STL file of the 3D print, and then you can get a simple free quotation and email to your email. So you can go to cb3d.circuitbasexcel.com and you can like upload the STL file, and you can also see like a live I think visualization of how that 3D print will look also. So I think that answered my question. Like answered that question.
Yeah.
I would like
when it comes to the cost.
Dylan, go on.
When it comes to the cost, it will mainly depend on the material that it consumes and the printing time. That's how the cost came from. Like if it prints very long time, the cost may be high, and it will, if we can print it in a small time, let's say 10 to 15 minutes, the cost will be really less, and also it will depend on the material it consumes. So it will be not much cost, like into 7 to 7 box. I think it is less than 400, 500, maybe less than that also. You can, Deepana told you also, you can go to the CB3D website. So you can get a quotation before you print. Okay. Sarutha, did you say something?
Yeah, that was what I was going to do. Yeah.
Right. I think this question we have answered previously, Lanka. The mounting holes.
There is two options. How did you add the mounting holes in the ECDA? There is two options. You can add the symbol from the schematic, and you can import easily through to the layout from the symbol. And also I did the method in the layout. There is you can place a pad. No, after placing a pad, you can set a drill diameter same as the pad diameter. So then you can make sure that there is a hole without any copper one. So that is an easy one. So anyway, you can import it as a component from the schematic also. Yeah.
And regarding the next questions, like how to choose proper microcontroller instead of Atmega 32 based on our project. So actually depends on your project. Most time, like it depends on like how much processing power you required in order to run your functions or maybe algorithms. So mostly depends on those algorithms kind of things, because like if you are using kind of a very heavy and computationally large algorithms, you should need enough like memory power also to store those things. And also if for example, let's think for a flood fill algorithm that we use in micromouse competitions, like it's kind of a fairly large algorithm, and like if you like while robot is moving in the maze, if you like the computation, like it's got very delayed to make those computations, then you might like hit or like get through with those walls. So like this kind of like when selecting your microcontroller, so it's basically depends on your project and your application. So and also like one of the things that I have faced earlier in well, it's like I was like using first Arduino Nano board to like write these Fabrication algorithm, and what I faced was like when storing those variables and this like cell values, cell walls, where are those cells existing in that cell, particular cell. So then my memory got exceeded. So then I realized that how I should handle with those stuff. So likewise, based on your application, it depends. So if your application is kind of large and your algorithm, you are using heavily algorithms and you need a very quickly responsive algorithm, you should go for a high, like you should go for a microcontroller that has like higher frequency, higher storage capacity. So these are the like kind of main things that you should be considered when selecting a microcontroller for your designs.
Yeah, and also I would like to add, like on top of what Charlotte has shared. So actually, so there are like this concept in IoT. I think you have like heard of IoT. So there are these classes in IoT that there are these three classes. Like for an example, I have this Atmega 328P here, and I have this ESP32, and I have another STM board. Like think for an example that you want to create an IoT device that communicates with the internet. So for that example, you would have to actually implement the the internet stack on top of that device. So for that requirement, the most requirement that would it need is a storage to store the the code that is needed for this HTTP transaction. So in that case, you would need to go for an ESP32. So you wouldn't need an Atmega 328P is not enough for that. So there are these like three things that you have to see, like either it's speed, or either it's storage, or the memory, or either it's computational complexity. Like for an example, this Atmega 328P is a 8-bit chip. Right? See, this is a 8-bit chip, and so this ESP32, as I remember, is a 32-bit chip, and this is also a 32-bit chip. And like in this STM one, this has a very high storage. That means the flash is really high, and so that means as Sharda mentioned, like in terms of your application, you have to select. Sometimes like even you can actually build an IoT application even using an like Arduino, but you can't actually interact with it. With the internet then directly. So then you have to use like some other kind of communication technique to communicate with the internet. So that is like so first you have to define your project and the scope, and then you have like you can either try two things, like you can build the project using the devices that you have, and then you have to figure out the method to do this, or in the other hand, you can figure out the thing that you are going to do, and then find out the specifications that you need to have in the devices to build it. So in these two ways you can do it. So that is up to you, and this cost-effective way might be the first one. Actually, I think I answered the question. So yeah.
Do we have any other question?
Yeah, I think this question is for me. If we print laser printer, what thickness, if that ink should be there? So I think so. It is so we can use the default setting of the laser printer. So that is so we don't need to think about thickness of in that. Dilanka, I think you have a question. That's okay. How do we mirror schematic before printing? So there's this option to mirror, I think, at the printing stage. Like, can we demonstrate that, Dilanka? I don't know if it's possible to demonstrate that now, but there's this option that where we can select to mirror the mirror when printing.
Yeah.
So next
there's this question on how to solve very small SMD components. So I just wanted to give a small idea on that question. we have shared a link in the chat regarding feedback, getting feedback on doing a PCB soldering session. So I think you guys received that form. So please fill that and let us know what you think about soldering session. We can like do some concepts on how to solder SMD components and those techniques. And
Sorry. Yeah, I think the questions are over, and so the last question is something that we are going to cover, and I would like to hand over to Charlotte.
Before that, I would like to show the PCB, like what we have printed. Before going to that, let me share my screen. Yeah, this is the PCB. What's look like? This is a Medibox PCB we printed from a local manufacturer. We will be giving you the contacts of that manufacturer in Charlotte's session, and this is how does it look like. Deepana is also told about these things. This is the screen printing method PCB, single layer PCB, Medibox project. I have another video regarding, yeah, here also, this is the final outcome of the Medibox. You can see the components are mounted, and all the seal screen, you can see button names and all the names are there. So you can get a exactly similar like output when you're designing after designing your Medibox and manufactured your PCB. Like Deepa told you 3 ways, and Charlotte now will tell you about one way how to manufacture from a foreign and professional manufacturer. And he will be introduce you how to do step by step. So follow this guy. Charlotte, over to you.
Yeah, thank you, Dilanka. So I'll start my session now quickly. So like now you guys know all the things about how to make PCBs and the best practices you should follow in order to make a PCB a good and reliable one. And also in the previous session, Deepan explained you about those different techniques we can use in order to make our PCBs as well. And also there is one thing to be noted here, like even though Deepan explained about you some of these DIY techniques we can use to manufacture our PCBs at home, to obtain a reliable and kind of a long lasting PCBs, you might have to make them using production level techniques. And in one of the Deepan slides, he told you about this as well. So some of steps showed in the previous session was actually included in those production level techniques as well, but in kind of a more accurate level. So most of the time for each of those manufacturing steps, specified machines or people who have the expertise at that particular step are used, and you will see some of them in my session as well. So I keep that in mind. So there is a whole next level of PCB manufacturing happening in the world. So like, for example, like you can manufacture a working PCB by following the steps in the previous session, but we cannot achieve to the level of production stage without those highly accurate equipments and the relevant expertise in that area. So with the videos like Deepana's videos, some of you guys might think like making PCB is kind of a hard thing. Actually that you might have that opinion. But to provide us that facility, there are many PCB manufacturers exist in the world. So they are doing what we want, and like we can just pay them and get the job done. So because of these things, like PCB designing things or PCB manufacturing things have become easier for us. So now first we will see how we can get our PCBs manufactured from global PCB manufacturers, and in a while you will also see some of those production level steps and some of their videos as well. So let me share my screen first. Yeah. I hope my screen is shared now. Okay, so there are actually many global PCB manufacturers you can find if you just Google it. But here we have mentioned several and famous manufacturers, especially from China. And like we have prior experience in even working with some of them as well. So like this JLC PCB, then PCB, all PCB, these all three are PCB manufacturers, Chinese PCB manufacturers. So I have even put the links in the slide so that like you can visit them if you are interested. But to like give you the experience of how to order your custom design PCBs, we have created a separate video. So I will play this video and explain the steps that you will have to follow in order to order your PCB from a global PCB manufacturer. So for this video, actually, I have chosen JLC PCB, but for any other global or like any local PCB manufacturer, all the same steps will be applied to get to a PCB manufacturer. So let's first go through this video. I will reshare again with optimized for video. Yeah.
This video will be a complete.
Wait, I will this. So yeah, I think all the things are okay. Yeah, so let's play the video.
Complete guide in getting your printed circuit board fabricated.
I hope you can see my screen, right? Can someone reply?
Yes.
Yeah.
By a foreign manufacturer. First, you will have to download the designed PCB as a Gerber file.
So the first step is downloading the Gerber files from the IEEE. So now you know how to do this. Like Lanka has already taught you how to do this. So I will not go through that step again. So let's continue the video.
IEEE. Simply click File, Generate PCB Fabrication File. Click No, Generate Gerber. Click Generate Gerber.
So the download the Gerber files will be downloaded as a zip file type, okay, and it will like you can see it's downloaded as a zip file format. So here you can see it is downloaded. So like if you have like LTM designer or like any offline PCB designing softwares, like you can open them and see how it look like. So in this video I will show you like how it look like in the LTM design. So like we have designed the PCB in ECDA, but like we can even open those Gerber files with another software. Okay. So we have a
content of the file by unzipping the downloaded
and here
file.
like you can see what are the includes in the that zip folder. Here like it says Gerber board outline, bottom layer, bottom solder mask. All the things are necessary for PCB manufacturing are included. So let's see how it looks like in LTM Designer.
File.
So I think you saw that, and you see like here is a board outline. All the things are okay. So
You
again,
have a
as you
number
can see,
of options
I have
to
already
get
mentioned those manufacturers like in the slide as well. So we will be focusing on JLC PCB.
Your designed PCB printed. In this video, we will be focusing on ordering your PCB through JLC PCB. For that,
So
visit the official website of JLC.
Like generating Gerber files into their JLC PCB official website. So to do that, you can go to jlcpcb.com. Okay, like write that in the search bar, any like your search engine, and just type OK. And then you will be directed to
PCB
here. So
through
like
the following
since
link.
most of you guys don't have an account in JLC PCB, you guys have to first create an account. So it's actually a very simple step. So I will show you that as well. So like you have to like click sign in button, and if you have already an account, you can just sign in using that account. If you haven't an account, you can click start here. Then you will be directed to here. Like also here you have two options to make a JLC PCB account. First one is like using a Google account to create your JLC PCB account, or else you can just type those username, email, password, job function, all these things manually and create your JLC PCB account. So but this one is the most easiest way. Like we have to just click those buttons. So we will be go with this button. Okay. It will direct it to here. Then now from here you have to select
use your own Google account or create an account in the website itself.
So after creating your account, you can see the name is shown here. So you will be again directed to here. So now it is time that we order our PCB. So here you can see there is an option called order now. So let's click order now. And
Click
here,
order now in the
after clicking
navigation
that,
bar.
you will be redirected to here. So in here, like you have to add your downloaded zip files that contains all those Gerber files. You can add them using clicking this add Gerber file button and select the location of your zip file, or else they provided us this drag and drop option as well. So let's focus on this drag and drop option, how we can drag and drop files to here. So we know this is a location, and
Select
now
your
we are
zip file
dragging
by
it
clicking the Add Gerber file,
and dropping it to here. So like,
or simply drag and
we
drop the
can
zip
easily
file
upload
here.
our Gerber files to
After
GLC PCB website. So after that, it will upload properly. You can see like it says that uploading your files. So it will take a few seconds, and then you can see your design file from here. So
the
like you
file
can see
gets
now your design is
uploaded,
shown
you
in
will
here.
be able
So
to
if
view
it
your
is not
design in the window.
showing in here, there might be an issue. So like you can again generate those Gerber files if you found any error. So also like here it says some of these options. You can see the number of layers you want in your
Select
PCB, and also like when differentiate between the number of layers, the price will also change. Will change. You can see it how it looks like when changing number of layers. You can see price will change because it is obvious that if the number of layers are increasing, the PCB manufacturing cost will also increase. Okay. And also usually the dimensions will automatically be updated when you uploaded those zip files, but you can adjust them if you have any needed, any requirement. And also in the JLC PCB, you can see the minimum order is 5 components, and like you cannot just order a one PCB, but don't worry those unless your PCB is a large. Unless your PCB is a large one, the whole cost is very cheap. As I remember, it was just like $2 for all those five PCB. Very much cheap and very much worthy because their PCBs are very much in quality and very much long lasting. Okay, so let's see. So like now you can like change these other parameters according to your need. As you can see, even the PCB color can also be changed according to our requirement. So let's see, now clicking is now clicking red, and the PCB is red, and now clicking blue, and the PCB color is turned into blue. So likewise, like you can change all these settings according to your need, and like it is your design, and you have the freedom to do that. So then after selecting all the settings as per your requirement, then you can click save to cart option.
Per your requirements.
Yeah, so after clicking that, it will show
all your PCB
the whole cost of your PCB that will go for manufacturing. Okay, this is only for manufacturing without shipping cost. So then you can check out and pay using your credit card or debit card or like any payment method you prefer. And like so when paying, you have to select a shipping method, and based on that you will be charged according to your shipping method. Because most of the time to manufacture your PCB's cost is very much less, but to get your PCB to ship to Sri Lanka, you might have to pay some amount of time. Okay. Okay.
Yes, are added. That is, you may check out your designs and make the payments.
So also in JLC PCB, they provide us a wonderful thing, which I will show you now. So like after placing your order, you can come back again to this page, and let's go to order history. Okay. So you can click this, your account name will be shown
also
here. Click
log in
that,
with your
and here you can see the order history. Okay. Then you can click that order history.
So and view the status of your order through the JLC PCB website
and on which state that they are at the current moment. So like in here, you can see we have some of the PCB orders that we have placed early. So like since those are like done a long time ago, you can see it says that production is completed. So it might not be the case for your case because like you are from your end, you are now just placing the order. So it is not yet production completed, even it has not yet started. So this is not for your case, but for demonstration purposes, now I'm showing you that in my case, the production has been completed. So like I can like click this, okay?
This includes.
So after clicking that, here you can see they have given us the steps of their PCB manufacturing process. And the interesting factor is that like they just not only given us the steps, but also they have provided us a small video showing those steps as well. So that's what I have mentioned earlier, like the production level manufacturing steps videos. So you can see how it is done.
Current
So like
status
now
of
you
your
know the file
PCB order.
types and steps needed to
So
order
through
your PCB from a global manufacturer. Like even JLC PCB provide you the facility of monitoring the stage in your PCB is currently in this small interesting video. So wait, I will again show you from my website. So let me again share my screen. Yeah, so this is the JLC PCB website. Again, let's go to order history. Yeah, still loading. Yeah, so here you can see all the orders that we have placed early. As I mentioned earlier, in your case, this will not be shown like this. Okay, so now you can let's click this one. So now you can see all the steps they are following in order to manufacture a PCB. So let's see some of these steps, like see how drilling is done. So let's watch that video. So you can see how they are using machines to drill those PCBs. And like if you are to use a DIY technique and drill those holes, you have to do it manually. And also it will be very hard to read accuracy level of these machines as well. So that's the difference and quality level in between those DIY techniques and those production level techniques. So let's see one of another state. Yeah, if you look at this electrical test. So like Lanka showed this step in his one of his previous session as well. So as you can see, those manufacturers have machines to test the electrical connectivity of their manufactured PCB. So like before sending those PCB to you guys, they are doing a validation that the PCB connections are properly there in the PCB. So, but the thing, like if we have manually manufactured the PCB by ourselves, we have to check those things, because without all the connections, our PCB will not work as we expected. So I hope you guys would an understanding about the differences and quality level in production manufacturing steps rather than making a PCB by yourselves. So actually those different kind of videos adding a solder mask, all the tips are here. So like this video all and those videos will help you a lot regarding understanding the steps of PCB manufacturing. So now I will not go through all those manufacturing steps since it is kind of a large process. And if anyone is interested, like you can Google those steps provided by JLC PCB for that each step, and then learn what happens in each of these steps. So actually that's all from regarding ordering PCB from a global manufacturer. Wait, I will go again to slides. Okay, wait. I'll share again.
this, you can have a clear idea about PCB manufacturing process too. Once the
Wait, I'll share again. Okay. I think my screen is sharing now. So I was talking about those global manufacturers. And so with some limitations, locally also we can found some PCB manufacturers. So like here I have mentioned few of them. Is my screen share properly?
Yes, sir.
Yeah, I think it's okay. Yeah. So like I have mentioned few of them, so few local manufacturers with their links so that you can try out them whenever you need it. Also, like I have mentioned the person like who have manufactured our PCB, Mr. Rasik Kamal, and he is also a resource person from ENTC you can contact. So I have mentioned his email and contact number as well. Like he's doing very quality work as you show from the video of Lanka shared with you, for even like prices like 250 rupees. So it is very low price, but with a high quality. So if you have any need, you can contact him, or like this Lanka Next, both of these are also local PCB manufacturers. They have that capability as well. So I think up to now, you know all the things needed in order to order your PCB from a global or a local manufacturer, and you guys know some commonly used manufacturers as well. So there is another major step that we haven't focused in. So can you guys think what it is? So far, like we have designed our schematics, then layouts, and now we have also placed an order to manufacture our PCB. So now kind of like we are kind of coming in a sequential manner, schematics, then layouts, then generating Gerber files, and then we have placed an order. So then what is missing? So can you like guys guess and give me an answer on that question? I'll just like give you a couple of seconds. Yeah. So actually, that's the thing. We didn't focus on our components yet. So actually, in some cases, people first search and find the availability of these required components. And then according to the availability of their components, they design their PCBs. But in most practical scenarios, after designing the PCBs, people will order the components. So this is kind of actually a crucial step since in order to work our PCB as we expected, the components with the desired values and desired characteristics are needed. So there are so much things need to be considered in order to order the right component. But for your understandability, we will not go much deeper into that, but we will give you how to start that process and how the process is done to order your components. To achieve this components ordering thing, there are actually various firms available in both the local and global aspects. In this Medibox, we actually have selected components like so that you can easily buy them from local manufacturers. You don't need to go for global manufacturers, but in most of the time, this is not the case. So you will have to order a component from an international manufacturer, especially if your PCB is a complex one. If you are doing SMD soldering or SMD kind of stuff, this is a definite case. So in the resource folder, like we shared with you, we have mentioned some of those local places to buy those electronic components. So today I will not go through the local manufacturers or local local electronic component suppliers, but I will show you the way of ordering a component from an international manufacturer. So let me share my screen again.
This video.
Yeah, so internationally, there are actually various organizations do this component supplying thing. So in this slide, I have mentioned few of them, so that in future, if you want, in order to like order some components, you can use them. So this LCSC, then DigiKey, some of you might even have heard them name as well. Then Mouse Electronics, Seed Studio, and Arrow Electronics. So like I have provided you with the links as well. So try and visit them if you are interested and see what they have in their websites. So now I will show you like how to use LCSC to order electronic components. For your convenience, I will try to order some components that you guys have already familiarized while designing the Medibox PCB. Okay, so like there are some things need to be considered when ordering components from a supplier. So the first one is, as you can see, choosing the supplier. So in this case, like you don't need to worry much about those stuff, like since we have already given you some of the good options in the previous slide, but this must be considered because sometimes due to their technological problems or their technologies, the components might be in bad situations, and also the cost can be changed according to their supply. In some cases, like some suppliers give it in a low cost, but another supplier give it a very high cost. And also regarding those cutting edge technology, you have to like go through some of the reviews that people have prior experience with working those suppliers, so that you can get an idea about are those components are in good quality or bad quality. So this kind of thing. So you have to be considered about when you are choosing the supplier. And secondly, like we have to like focus on whether our selected supplier has a suitable filtering method important. Without this facility, it will be hard for us to find a required component in a convenient manner. So you will see a couple of minutes what I meant by this filtering thing. So if you don't get it that now, just don't think, okay. And finally, sometimes like when ordering components, we will not find the exact component that we want. So in the earlier as well, I mentioned if we cannot find the exact component, we should find the most suitable component that nearly satisfy all the specifications we require. So if your design is complex and like critical to slight deviations of the required specifications, you should be aware about your selection. So actually to do that, you should have a good understanding about the electronic part of your design circuit as well. So that's why I have answered one of the questions in the previous Q&A session, like it is better if you have a good understanding about what is happening in the electronic part of your design PCB, so that you know what will happen and how we should order components according to that requirements. Okay, so like actually this step is usually done by using the third step that I have mentioned here, which is reading the data sheets of the selected component and matching with your requirements. So I will show you this thing as well in a while in a very basic manner, so that you will get an idea about the process. So, but you don't need to worry much about these things for now. As I said, like those things become important when your designs are very critical and sensitive to those slight changes in the components. So now let's LCD side and order resistor like a capacitor or maybe a transistor, that you get familiar with the process. Okay, let me go to the website. Okay, let's close this one and let's type LCSC. You can see. So this is the official website, lcsc.com. You can type it and you will be directed to here. Yeah, so since I have like already logged into my LCSC account, I have been directed to here. So if you don't have any account in LCSC, it's same as the process I showed in making the account in JLC PCB. So that's actually a very simple step. So I will not explain again that. So now we are here in the home page. So first see how we can order a resistor. Okay, so let's type a resistor here and type enter. Yeah, so now you can see the search results gave us various kinds of resistors, chip resistors, shunt resistors, through-hole resistors. There are various types. So like now you guys will get an understanding about how many types of resistors are there as well through this, so that you can use them in your PCB. You only like seen SMD or through-hole resistors, but there are various types of resistors you can use in your PCBs that according to a requirement. So you can learn those things as well from like you're using those kind of things. So like, but in the Medibox, like we uses through-hole components. So let's select through-hole resistors for that. So now you can see it will directed to here. Okay. So now again, you can see there are some various categories mentioned here, like you can order your resistor from a desired manufacturer. Then basically the package means the size and physical parameters like width and length, how should be there in your resistor. Then the type of the resistor, then the resistor value, the tolerance. Tolerance means how much it can deviate from its specified value. And as you can see, there are many other things we can use to filter our components according to our exact need. So for now, let's see a resistor with 1K ohm value. Let's type 1K, you can see. And also like, assume that I want the resistor from Uniroyal manufacturer. Okay. Basically like I'm just doing this for demonstration purposes only. Okay. So don't focus about the components that I'm selecting. They might not be correct with our Medibox thing. But just focus on the process I'm used to filter those components as per my requirement. Okay. So like if you want to remove any selection, you can click this reset button. So it will not be selected then. But since I want now Uniroyal manufacturer, so I will select that. Then click the apply button. Okay. So yeah. So now you can see there are like various options we can see after the filtering process. You can see the availability, how the pricing will change with the quantity, the manufacturer, and the small description as well. So to order your component, it should be in stocks as well. So if it is not, you have to find another component that satisfies your requirement. So that is why I mentioned you earlier that you might always not have all the desired components you need. So in that case, you have to find components that nearly satisfy your requirements. So that's why I mentioned like to do that, you should have a kind of understanding about the electronic stuff behind your design circuit. So I hope you are getting my point. And also there's an important thing here as well. You can see they have provided us a data sheet. So in this data sheet, they have provided all the physical and technical details of their company's manufactured resistors. Okay, so let's briefly go one of them. Okay, this. Wait, I will hide this because it's kind of disturbing for me. Okay. Yeah, okay, now, okay. Now I'm here. So this is the data sheet they have provided by the unit oil manufacturer. Let's scroll down a little bit. Yeah, so in this data sheet, like you can see, they have provided all the things they have included in their document. Let's see what is, scroll down a little bit. Yeah, so now you can see they have like saying that what is included in this document under the scope, under this scope section. And as you can see, they have provided us the ratings and dimensions here as well of their manufactured resistors. So by looking at these things, we can really identify whether these components manufactured by this unit oil is suitable for our requirement or not. For example, if we require the length of our resistor as 6.5 millimeters, this length should be 6.5 millimeters, then we can select this option. You can see they are this type of resistors and the L is 6.5. So that's the main point here. So there are many other details if needed. So you can choose the most suitable component according to your need. So that's the main point here. So I hope you guys get the basic understanding. So let us add this to our card as well. And also in the LCSC, also we have to order minimum component, and you saw in the JLC PCB as well, it has 5, but here it says 50. And also this minimum number of components will vary with the component as well. So even though it says here as 50, don't worry much about it, because for the whole 50 resistors, the price is very small, even under a value of $1. As you can see on the pricing section, it is very small with regard to resistors. Okay. Now let's order a capacitor. Okay, just type. So again, you can see there are various types of capacitors here. So let's go for ceramic disc capacitors, since we have used some of them in our Medibox. So now again, you can see as previously, we have several options here. For example, as I remember, we have using 22 picofarad in our capacitor, two 22 picofarad capacitors in our oscillator section. So let's search for that 20 picofarad. You can see it is here. And also here in this lead spacing means the gap between your capacitor legs. For example, let's say we need a 5 millimeter gap, because we have designed our PCB to place a cap that has 5 millimeter gap in between its legs. Okay, since this is demonstration purposes, let's only consider those two. So, but in real case, you might have to consider those other things as well. Okay, I'm just doing guiding you on the process. So after that, click apply. Okay, yeah, so you can see several options here. Now again, we can see the data sheet here. Let's scroll down a bit. Yeah, so you can see the dimensions and the characteristics of their manufactured capacitors. So as I previously mentioned, you can select your capacitor accordingly by referring to this data sheet. So let's add, yeah, here it's also said 50, but don't worry about the price. You can see it's a very low price. Just add it to our cart as well. Now we know we have used PC547 transistor in the Medibox, but assume we don't know the exact part name, and we are just searching for a suitable type of a resistor, suitable type of a transistor. Okay, but we know it should be an NPN transistor. That we should know. That we are knowing that we have to use an NPN one, but we don't know, or we couldn't find a BC547. Think of like that, but we know our. Yeah, okay, I go to slides first. And also guys, for transistor, I have added the steps I will be demonstrating now in the slide, you can see, but I will not refer them now, but you can see them if you want. Okay. So we have type transistor here. So we know we know the type we want is NPN. So here you can see capital NPN. So click that. Yeah. So since the type we need is NPN, we can go with then this one. And also in the slide for you, yeah, the packages that transistors have. So basically, like if you choose a wrong package, it will become a problem for you, even your other requirements are satisfied. Because like yeah, tune to here. And also remember, yeah. So as you remember, like we use a transistor to control the current flows through the buzzer. I hope you guys remember, like. So like if we know the maximum current that the buzzer can handle, we can choose this transistor accordingly as well. Okay, I will wait to show you first, like yeah, this was the one we have tried out. So let's say like our buzzer can handle up to 50 milliampere. So then the IC, which is the collector current that flows in this path, should be set to maximum of 50 milliampere. So like if we choose a larger value for that, there might be a possibility that we burn our transistor in some instance, because electronic stuff, some random things might be occur. Okay. So likewise, we can restrict certain things as well as we required by choosing the right components. So I hope you guys got that. See this option to select requirement, assuming like our buzzer can handle a maximum of 50 milliampere. Say, let's select this as like 50 milliampere. Okay, so that I'm like thinking like now my buzzer is kind of safe by the transistor. Okay, so for now, let's move forward with the options. So now you can again see some of the options here. So let's first see a data sheet. And here you can see the package style, which we have used TO92, and all the required ratings and characteristics you need in the designs here as well. And yeah, and further you can see the graphs of the transistor here. From these things, like you can identify how the transistor behaves with the conditions as well. So actually this is very useful, and you can select your components very easily through them. So let's like here is minimum number, increase to 20. Previously the minimum quantity has also being varying. Okay, let's add 20 to that. Yeah, so let's see one more example. So you know, need a voltage regulator in our Medibox. So like when designing, we use LM7805. So in the transistor example, I showed you the way of searching a component when you don't know the exact part number, but only using the specifications. You found the you found the NPN transistor based on specifications, not with the part number. Because if you are using the part number, I can like directly search for BC547. But I haven't done that. What I did was like searching from the specifications, and I found a suitable component. But since like I want to demonstrate it the other way, I will search it from the LM7805. Now I know exact part number. Just search that. So like is a dropout regulator, so it's in this category. So let's click that. So in here, like you can see output voltage, which is what we require. And also let's select the package to TO-T20. Okay, better so T20 package. So you can see this is a TO-T20 package. I hope you guys know these packages kind of up to a level. Like this is the one using the LM7805. Okay. And so I think that since the demonstration, I will only go with these options. Like if you want to check other options, you can go through them as well. Okay. So let's go through the data sheet. So now you can see the package style. So this is the one we want actually. And the maximum voltage like to give to this component is 35 voltage. And as usual, other specification can be here as well. And yeah, even the circuit is shown here as well. So you can use the data sheet to like refer how it can be connected to the circuit as well. Okay, like other graphs as well as in the previous transistor thing, you can see here how the regulator behavior conditions. For example, like if we choose this graph, like it says that to output 5 volt, the input must be greater than greater than like 5 or 6 voltages. You can see if the voltage is less than 5 voltages, it will only output less than like voltage. To get the maximum output of 5 voltage, that is what we require. So that if we want to get 5 volt out from this component, we have to give at least 6 voltages to this component as input. Like very easy kind of things you can use to like filter your components and search whether they are satisfying your requirement or not. Okay, so now like I hope this wait. So you can see this component is not in stocks. As we did now, we can go through this other data sheets again and like see the suits for our requirement. And for now, I will not go through again data sheets. Like for assumption, let's say like this one satisfy my requirement. So I have like assuming I have go to this data sheet. I hope this will satisfy my requirement. So I will order this one. Okay. Okay, now like I have already ordered for main component categories. So I think my order is completed. Now I should proceed. So now let's go to our cart. So here you can see all the components that I have ordered. And to confirm, let's see whether they are correct. Like I have ordered the TO. Okay, the package has been different. So it will not satisfy my requirement. It again, yeah, this one might be okay. So likewise, you can correct according to a requirement. So this one is okay. It is done, and this was not. We don't need this kind of a package for LM7805. We will delete that, and now we can see NPN 50 milliampere. This is what we want from the transistor side, and 20 picofarad capacitor we don't need, and also a 1 kilo resistor we need. So as you can see in the right side, like we can see the total cost, and you can see some of those additional costs have been added as well for handling those components things. So those are actually normal things, and no need to be worried about that. And also the weight of our package is shown here as well. And like finally, we have to like select a shipping method. So let's say we want these parts in a very urgent manner. So because of that, we need our package to deliver within like 3 to 7 days. So we can select DHL Express, but you can see it's a higher cost. But since it is urgent, let's proceed with that. Okay, so then like we can click secure checkout. Yeah, so here you can give you the like your address, and then after this you can see after giving the address you will be directed to again to the shipping method. So you have to again like select the shipping method you preferred, and then in the finally you will be directed to a payment gateway. Okay, so in here you can like use MasterCard or like a credit card or any preferred paying method so that you can pay your order. So that's it, guys. So now you guys know how to select the components that best suit with your requirement, some basics of reading data sheets to get help on that, and also the way of ordering it. So I believe you guys understood what I showed. As I have mentioned earlier, like when you are designing complex and critical PCBs, not only those basic things that I showed you, but there are many things need to be considered with your electronic and electrical knowledge. But as a start for that journey, I showed you those things. So guys, who knows what is the process and how we can order a PCB and how we can order our components according to our requirement. So these kind of things also will be developed with your experience. So while we are doing this, you guys will get the experience. This is not like a magic or some kind of thing. If you are doing this, you will generate that skill. So that's it, guys. And thank you for listening to me. I think today's session will be stopped from here. And in the next week, we will be looking deeply into those embedded programming stuff and in-depth microcontrol stuff. So that session will be very useful since like it has more advanced stuff, and like you need to know if you are interested in embedded stuff in your future career. Yeah, so that's it from my side. Thank you guys for listening to me.
And also, thank you, Charlotte. And I would like to do a small announcement. I think, like, even though we have like this participant right now, so we have been sharing this feedback form for soldering session that we are trying to organize some session in the next week or some later date. So you can go ahead and give your feedback of that. So depending on that feedback, we would be trying to organize a session for you, either like that can be a live session or we might be uploading a video. So please give your feedback on that. Thank you.
And like there was a question saying like, can you show us where we can order equipment from local shops? Wait, I will show you the resource folder like we have shared with you. Okay, I'll share my screen again. I think you can see my screen, right?
Yeah, yes, sir.
Yeah. So here I like we have mentioned several places you can buy your electronic components from locally. These actually things are embedded in the workshop resources folder we have shared with you guys. So that in here you can see Medibox budget. In that in that PDF, you can see those things. Okay. So you can just like here Cyan Electronics, Alphatronic.lk, Nilambar Electronics, Tronic.lk, Lankatronics, all the things are there so that you can go to their websites and order your components. I hope I gave you your answer. Okay.
And also, Charlotte, if someone manufacturing from that Mr. Amal, then they can, I think, get solders also.
Yeah.
The components, they can get a complete package.
Already assembled, and also you can arrange the shipments as well.
Yeah.
Yeah. Then now I would like to handle back the session to the SLI team. So I would like to invite Sevandi.
Thank you, Deepana. So we've reached the end of the third workshop, and once again, thank you for being such a wonderful audience and actively participating throughout the session. We would also like to thank our resource persons, Mr. Lanka Vikramasinghe, Deepana Ishthavira, and Charlotte Rajapaksha for delivering such an amazing content. And also, we would like to thank our SNS partner, ULEAD, for generously collaborating with us. And again, a very quick reminder on the session that will be conducted on the coming week for the students who completed their A-levels in 2020. We will be conducting a session which will guide you on how to fill out the online application for university admission. So connect with us on our social media pages to get to know more about this session. We will be posting on our social media. So don't forget to pass this message to whomever might be interested. So our next workshop will be next week. So thank you and see you next week.